Good morning to one and all gathered here, and welcome to Raerest 2016, International Conference on Global Colloquium in Recent Advancements and Effectual Researches in Engineering, Science and Technology. Let us begin this day with a prayer song. May I invite the college choir to render the song.
I just keep trusting my Lord as I walk along. I just keep trusting my Lord, and He gives me a song. Though the storm clouds darken the sky, oh, the heavenly train, I just keep trusting my Lord. He will never fail. He's a faithful friend.
He's a faithful friend.
Such a faithful friend.
Such a faithful friend.
I can count on Him.
I can count on Him
To the very end.
to the very end.
I just keep trusting my Lord as I walk along. I just keep trusting my Lord, and He gives me a song. Though the storm clouds darken the sky, oh, the heavenly train, I just keep trusting my Lord. He will never fail.
I request the dignitaries to kindly shift to the dais for the function. I now invite Dr. C.J. Joseph, principal of our college, to deliver the welcome speech.
Esteemed guest of the day, Dr. George Ofori, Dr. P.J. George sir, our project director, Reverend Father Matthew Koranguya, manager of our college, Dr. Lijo Paul, organizing chair of Raerest, invited guests, respected heads of departments, staff members, all participants of this international conference. It is with immense pleasure I am standing before you on this auspicious occasion of the inaugural function of the first Global Colloquium on recent advancements and effectual researches in engineering, science, and technology. As you know, our college, SKCET, is a new generation self-financing engineering college established in the year 2002 under the Catholic Diocese of Palai. At present, the college offers BTech courses in 6 branches, MTech course in 7 specializations, MBA and MCA. From the very inception, our college has been giving top priority to the quality and standards of its various programs, and this has resulted in good examination results and excellent placement records. SKCET aims at the holistic development of its students, and for that, we have provided all facilities here in our campus. Now, regarding the international conference, this international conference is a joint effort of all engineering departments of our college. We have received more than 300 papers and for this conference, out of which 180 papers will be presented here in the conference today and tomorrow. Our staff members have taken much pain and they were working for the last 1 year for the successful conduct of this conference. I take this opportunity to thank our staff members for all their efforts for the smooth conduct of this conference. Now let me come to my duty. Our chief guest, Dr. George Ofori, is with us now. He is professor at the Department of Building, National University of Singapore. He is a fellow of the Chartered Institutions of Building, Royal Surveyors, and Society of Project Managers, Singapore. He is currently the director of Multidisciplinary MSc Environmental Management Program. He is also a fellow of Ghana Academy of Arts and Sciences. His research is on construction industry development, international project management, sustainability in construction, and leadership development in construction. Also, he is now the deputy chairman of the International Board of Construction sector. On behalf of the staff and students and all the participants here, I welcome Professor Dr. George Ofori to this function. Next is our project director, Dr. P.J. George, sir. As you know, he was the principal of Tichur and Trivandrum Engineering Colleges. Then he was the director of technical education of Kerala State. After that, he was the first entrance commissioner of the Kerala Government Engineering Entrance Examination. And after that, he was the honorary secretary of Indian Society for Technical Education for nearly 10 years at New Delhi. Now he is our project director. On behalf of all the participants and staff members and students, I welcome Dr. George sir to this meeting. Next is our beloved manager, Reverend Dr. Matthew Korenguda. He joined this institution as the manager in the first week of February, and before that, he was the faculty member in Magar Agustino's College, Ramuram. On behalf of staff, students, and all participants, I welcome Father Matthew Korenguda to this meeting. Next is Dr. Ligia Paul. He is a faculty member here in the mechanical department and also He is the organizing chair. And he took his MTech and PhD from IIT Madras. Now, on behalf of the staff, students, and participants, I welcome Dr. Lijo Paul to this meeting. We are also blessed with a team of technical experts and subject experts for the conference. On behalf of SJCET, I welcome Professor C.R. Gaudar from Civil Engineering Department, IIT Madras. Professor C. Balaji, he will join only tomorrow. Dr. Anirban Basu, the President, Computer Society of India. Dr. Somashekar S. from Mechanical Engineering Department, IIT Madras. Dr. Benny Raphael, Civil Engineering Department, IIT Madras. Dr. Elizabeth P. Cherian, Electrical Engineering Department, NIT Calicut. And Dr. Dilip R. Nair from Electrical Department, IIT Madras. He will join us only tomorrow. Now, again, I welcome all the participants, all the invited guests, and staff members of SJCET, and also the students of SJCET to this meeting. Thank you. Thank you.
Thank you, sir. I now invite Dr. P.J. George, Project Director, to deliver the presidential address.
Dr. George Ofori, Reverend Father Matthew Koramkura, Dr. C.J. Dr. Lijo Paul, distinguished professors from IIT, NIT, President of the Computer Society of India, heads of departments, and participants of the conference. Today, our college is organizing an international conference, Singularis, that is human empowerment through technology. It is a global colloquium on recent advancements and effectual research in engineering, science, and technology. We are glad that so many distinguished persons are here to participate in this conference. For presenting papers, researchers have come from all parts of India. We have tried our level best to make suitable arrangements for this conference. If there is any shortfalls, I request you kindly to excuse us. Now in India, there are around 3,500 engineering colleges with nearly 70 lakhs of admissions. According to some reports, among the pass outs, only around 70 to 18% are employable. It is also found that in around 70% of the engineering colleges, teaching is below standard. The major task before us now is to improve the quality of teaching. Among the top 200 universities in the world, it is reported that there is none from India. It is really a shame for all of us. We have to study this problem very elaborately and take necessary steps to improve the standard of our university education. Compared to many world-class universities, very few institutions in India have international students. These international students, by their hard work and discipline, give a distinct and better reputation for the institute. Another major factor in coming up to the level of reputed universities in the world is the lack of importance given to research and development work. Research work should be a major activity of faculty and students. All research work should lead to patents and new products. Interdepartmental research activity should be encouraged and suitable incentives given to those engaged in research. In India, for most of our manufacturing processes, we buy technology from other countries at a great cost. We should try to develop our own technology for our manufacturing products. Our aim in organizing this international conference is to motivate our teachers and participants to do research work which will lead to new patents and technologies. I am happy that so many persons from all over the country have responded and have come here to present their papers and take part in the conference. I hope and wish that they will have a very pleasant and memorable time in this institution. I take this opportunity to thank Dr. Ofori and other distinguished professors from IIT, NIT, and the President of the Computer Society of India for having come over here to participate in this conference. I hope that this conference will proceed as planned and will come out with many new developments and proposals. I wish that all our universities and institutions will give more importance to research activities in future, so that in the next few decades, we will have our own technologies in most of our manufacturing activities. I hope and wish that the conference will proceed smoothly and will come out with valuable recommendation for the future. I wish the conference all success. Thank you very much.
Thank you, sir. I invite Dr. George Ofori, Professor at the Department of Building, National University of Singapore, to inaugurate the International Conference Raerest 2016 by lighting the ceremonial lamp. I also invite the dignitaries on the dais for the ceremony.
Good morning. I've just been told to say that the conference is inaugurated, but before I say so, let me start by saying I'm really grateful to have been given this honor. I've organized many conferences, but I've never been a guest of honor. It is a fantastic honor, and for this, I thank your school for inviting me to come. Okay? The way here reminds me of my country. I come from Ghana, and I come from a hill country. And so, coming here, going up and down, and also seeing the valleys and so on, reminds me of my hometown, where my parents were born. And I wasn't born there, but I was born in another town, but I would always go there. Okay? And so I'm happy to be among brothers and sisters, and I'm hoping that you have a fantastic conference. The opening speeches have been very inspiring, and I'm hoping that, in fact, in the end, this is what we want to achieve, that we get from here ideas that will improve our research. We get from here ideas that will improve our teaching. The theme of the conference is empowering the citizens of India, okay, through the work that we do. And I'm hoping that we would actually take this to heart and think about it every single time. Think about it anywhere we are, and think about it whatever we are doing. Because what we are doing, we're only doing it. Let's just not forget, we're only doing it because of the less advantaged person in our country and in the world. Okay, I will get the opportunity to say a little bit more, but I'll use this opportunity to say thank you, especially to the two fathers who are here. I'm a Christian, and I must say thank you first to the pastors, the fathers who are here. All right, then I'll also say thank you to your principal, but I will say thank you also to Dr. Lijo Paul. Lijo has worked extremely hard to get me to come here. He wrote to me, and in fact, Dr. Benny Raphael, my former colleague, wrote to me and said, your school wanted to invite me to come and speak. And I said, well, but I've never heard of your school. So he sent me a website, and I went to see your website. My aim, you heard the principal saying that my interest is to try to improve construction industries in developing countries. So I'm a construction person. I'm also a developing country person. And my aim is to see what I can do as a person, to make sure that we uplift every single person in every developing country and in fact in the whole world. So I'm hoping that all of us will come together and join together, learn from each other, and go away with big ideas to improve what we do to better humanity. Thank you. Oh, hey, I'm failing my duty. So having said that, I would say our conference is inaugurated, and I wish you all a fantastic conference. Thank you.
Thank you, sir. I invite Reverend Father Matthew Koramkura, Manager, SJCT, for the felicitation.
Respected Dr. P.J. George, the project director of this college and the president of this meeting, respected Dr. George Ofori, the chief guest of this conference, respected Dr. C.J. Joseph, the principal of this college, respected professors who are here as the subject experts of this conference, and dear professors and assistant professors and other staff members of this college and other participants of this conference. This is a moment of joy and satisfaction for St. Joseph College of Engineering and Technology as the curtains rise for Raerest 2016. It is indeed as an honor vested upon me to felicitate the chief guest, the keynote speakers, and all those who have gathered here. The college has always been a center of excellence. Right from the very inception of this college, our goal is to develop this institution into a world-class, pace-setting Institute of Engineering and Technology with distinct identity and character by offering a variety of programs and services that meets the goals and aspirations of the people. Raerest 2016 is indeed one step into the future. This will be a landmark in the history of this college, SJCT. An international conference of this strata and magnitude needs a proper organization. I take this opportunity to congratulate the entire team of Raerest 2016, the teaching staff, the non-teaching staff, and the student volunteers for making this event possible and fantastic. I do congratulate wholeheartedly the organizing committee for arranging this conference. May I take this opportunity to felicitate Dr. George Ofori, the chief guest of this conference. Your vast experience and expertise will make Raerest 2016 remarkable and unique. I really appreciate your generosity in accepting our invitation and for being with us here today. The entire congregation is privileged to listen to you. We are indeed blessed with a crew of technical experts and subject experts. Dr. G.R. Dodagaudar, IIT Madras, Dr. Anirban Basu, President, Computer Society of India, Dr. Somashekar S. Hayarmath, IIT Madras, Dr. Benny Raphael, IIT Madras, Dr. Elizabeth P. Cherian, NIT Calicut, Dr. C. Balaji, IIT Madras, Dr. Dilip Nair, IIT Madras, forms a perfect blend of intellect and technology for the conference. I express my sentiments of gratitude to each and every one of them for accepting our invitation and for being the keynote speakers for this conference. Last but not the least, I wish all the best to all the participants who have gathered here. Students from various engineering colleges in and outside Kerala are presenting their papers in this conference. I assure you that you have come at the right place. The participants have got one in a lifetime chance to interact with multiple outstanding professors from various technical fields. I wish all the very best to the participants. Good luck in presenting their technical work. John F. Kennedy once told, the greater our knowledge increases, the greater our ignorance unfolds. I wish this conference all the very best. Let our knowledge increase, let the darkness recede, and thereby the name of God, the Creator, be glorified. Thank you very much.
Thank you, Father. I now invite Dr. Lijo Paul, Organizing Chair, Raerest, to propose the vote of thanks.
Honorable Chief Guest of the Day, Dr. George Ofori, our Project Director, Dr. PJ George, our Manager, Reverend Father Matthew Korankura, our Principal, Dr. CJ Joseph, distinguished guests from IITs, NITs, President of Computer Society of India, and all the participants from outside, and all my colleagues, a warm welcome to you all. It's indeed a proud moment for St. Joseph's College of Engineering and Technology. This is a day all toil, the hard work, the dreams of the college take wings and soar to reality. Yes, Raerest 2016 is indeed the bedrock for technical excellence. I stand here as a proud organizing chair of this international conference. Let me express my gratitude to the eminent personalities on the dais and off the dais. First and foremost, let me thank the God Almighty for His grace in abundance, for being guiding star throughout the journey. No international conference of this stature and magnitude is possible without the brain of a visionary. Dr. PJ George has always taught us to tread the right path to success. With immense pleasure, I thank our project director, Dr. PJ George, for being the source of inspiration and for being the president of this conference. Dr. George Ofori, professor at Department Building, National University of Singapore, has been our dearest chief guest of this conference. It's indeed a moment SJCT would love to write in the history books with golden letters. With great pride and humility, I thank Dr. George Ofori for accepting our invitation and being here amidst this gathering. Thank you, sir. Reverend Father Matthew Korankura, in his early days as a manager of SJCT, has shown that he is a man on mission. On behalf of the organizing committee, I express my sincere gratitude to Father Matthew Korankura for his untiring efforts in making this conference a success. Dr. CJ Joseph, the heart of SJCT, has always been helping hand for all the events of the college. He has always inspired us with his ever approachable nature and kindness. This conference owes a great lot to the principal. On behalf of the entire staff of SJCT, the conference team, and thank you, sir, for all your efforts. Raerest 16 is blessed with a team of experts and eminent personalities from IITs and NITs. We have Dr. Professor Dodagowda from Civil Engineering Department and Professor Somashekar S. Hiramath from Mechanical Department. Both are my gurus and my mentors. And what I am here is because of their guidance throughout my last years in the IITs. I express my sincere thanks to both of you for being here. Dr. Benny Raphael, professor from IIT Madras in Civil Department, has been here for us for sharing his ideas. I thank you, sir, for coming over here. Dr. Anibaran Basu, President, Computer Society of India, is kind enough to come over here to preside as a session chair and keynote speaker in computers department. And thank you, sir, for coming over here. Dr. Elizabeth Picherian, Professor NIT at Calicut, was kind enough to come over here as a keynote speaker in Electrical Engineering Department. And thank you, ma'am, for coming over here. I take this opportunity to thank all for accepting your invitation. And on behalf of the entire team of Raerest, I thank you all for your esteemed presence. No program is a success without a wonderful audience. We have participants from all over India who have come over here for presenting their technical papers. So on behalf of the organizing committee, I thank all the external participants who have come over here for the conference. We have our bursar for Jose Therapel, who is always supporting us for all arrangements and all financial and every support. Whatever we require, he is there for supporting us. Thank you, Father, for all the support throughout these days. Also, we have the heads of department from various departments who has come out here. And as you know, this conference is actually going on at 6 major venues with the keynote speaks in various departments. So I thank all the head of the departments for organizing this in a wonderful way. Thank you all. Last but not the least, I thank all my colleagues from my bottom of my heart. I congratulate them for supporting. Let's in all the ways. Let's make this conference be a platform on which you pave the way for your technical excellence. Thank you all. Come experience Raerest 2016. Thank you all.
Thank you, sir. I request the dignitaries on the dais to kindly shift to the front row. We have come to the end of the inaugural section. The next section of the day is the keynote address, which will be delivered by our guest of honor, Dr. George Puri. Dr. George Ofori is the Deputy Chair of the Construction Sector Transparency Initiative Interim Board. He is currently a professor at the National University of Singapore and the director of the MSc Environmental Management Program at NUS. Professor is a co-director of the Center for Project Management and Construction Law and is also the guest chair professor at Tsinghua University, Beijing, China. Professor is a fellow of the Chartered Institute of Building UK, fellow of Royal Institution of Chartered Surveyors UK, and fellow of the Society of Project Managers Singapore. He is also a fellow of the Ghana Academy of Arts and Science. Professor has authored 5 books, nearly 100 international referred journal papers, conference papers, and book chapters. His research areas are continuous improvement of the construction industry, sustainable construction, and construction human resource development. Dr. George Ofori has shown keen interest in the improvement of the construction industries of the developing countries. He was the founding coordinator of the CIB Working Commission 107 on construction in developing countries of the International Council for Research and Innovation in Building and Construction from the year 1997 to 2007. He has been a consultant to international agencies including Australian Agency for International Development, the International Labour Office, United Nations Human Settlement Programme, and various government organizations working mainly on the construction industry development. He has undertaken major consultancy assignments in Malaysia, Bahrain, Botswana, Ghana, Indonesia, Singapore, South Africa, Swaziland, and Tanzania. Today, Professor is going to talk to us on human empowerment through technology. I invite Professor George Ofori for the keynote address.
So, is it possible to see the laptop?
Yeah.
Or we can do that. Thank you. Yeah, okay. Well, good morning again. I have about 80 slides, and much of it, you can, those are especially those at the back, they cannot see. So what I have done, I've also written a paper. So later on, you can ask the organizers to give you the paper. A lot of the information, everything that is on the slides, apart from a few pictures that I'm going to be showing you, is in the paper. Okay, so I suggest that you read the paper later on at your own leisure, and then you would actually see what I was trying to say when I was standing here. Okay. Again, I thank your college for inviting me, and from the video I could see, because we were looking from the air, I could see that we have a beautiful campus. So I hope I'll come again in future and maybe spend a few more days with you and see it in greater detail. Okay. All right, I'm going to talk to you today about how we can use our knowledge as engineers, okay, to empower the poor people. Okay, to empower people in India, because this is what your conference is trying to do. I'll come back to this later on, but let me go forward. I'll show you this. This is the Sustainable Development Goals, 17 goals, 17. And these are what our leaders around the world have signed on our behalf, that all of us, every country, and perhaps every person should be trying to attain these 17 goals. Now, what are they? I'll show you this. I've done this grouping. All right. The first one is to try and deal with poverty. Make sure that people well, and also give people something to eat, address their basic needs, as the economists will say, meet their physical requirements, very simple, basic physical requirements. Okay, so address their basic needs. That is the first one. All right. Now, if we do that, then we would attain some of the results that are on the other side. Okay. But I come from construction, and I think some of you engineers also come from construction. All right. There are two tasks, two of the goals that we must address. The one that I want to highlight to you is number 11. Okay. Just have a look at goal number 11. And this is what it says, that we must make cities and human settlements inclusive. Making them inclusive means making sure that everybody really feels that they belong to the place, all right? Make them safe. Making them safe also means designing them, planning them in such a way that people's physical safety is not at risk. What is this physical safety that I mean? Firstly, crime, but also natural disasters. You hear of floods, you hear of earthquakes, you hear of typhoons, you hear of various happenings that will take people's lives and also take people's living away, take people's income, take people's savings away as well. That is where resilience comes in. And the final one is sustainability, a key point, which we shall be also coming to later on. The next group is the one that comes as to what all of us must do together. Okay, no single country can address all these. It is a joint effort. All right, and the one at the bottom on the left-hand side is the fact that we need some countries need help, and this is where we're calling on those who have more to give, so that those who don't have enough can actually also do well. Nevertheless, we use resources, and that is why I also have on the right-hand side what we must do and how careful we must be in using our resources, addressing the issue of sustainability in a key way, in an important way. Okay. If you want to look at the future, then this is it. We want a future that is fantastic for all of us. We want a future where we have not just a safe place, a beautiful place where people can attain their highest possible aspirations. It's also going to be a future that we can only attain by working extremely hard. And you as researchers, you as engineers are going to be called upon in a very big way to play a role in this. I'm thinking. Let me get to the end, then I'll see whether I'm using the right file or not. Okay. Yes. Sorry. Yes, I am. Okay, so this is where we were, and I'm saying the year 2050, by the year 2050, you and I, as people working to develop built environments, would have to work extremely hard because the challenges are going to be more and more and more, okay? And so then we ask ourselves, what are we going to be doing? I'll skip this, and I'll also skip this, and I'll come back to this one. But I will show you this only to, to get you to think a little bit. We'll come back to this one also later on. But I wanted to tell you the summary of what I have in mind, just in case I don't get to the very end. All right. The theme of this conference is human empowerment through technology. Okay. So I asked myself, what is empowerment? All right. Engineers don't always define, but people like me who work for poor countries, we must always define. So what is empowerment? You empower a person by giving him the ability to look forward to tomorrow. That means you take away his worry about his basic needs. That is the first one. addressing the needs of the poor. So, making sure that the person is no longer poor, no longer struggling, no longer thinking whether he will live from day to day is the first example of empowerment. So make him look forward to the future. That is empowerment. The next one is to give him the knowledge, okay, to know where he is, where she is, and to also know what he or she can contribute. So that is knowledge that comes next. The next one is then to give him that is where then the power comes. Give him the opportunity to participate in choosing his or her own leaders, right? And the very final one is to give him the information that enables him or her to take action. And all these are things that we are going to be trying to address today. Under the areas that you are looking at in trying to address this theme, there is one called civil engineering. And the one called civil engineering has the 5 areas that we have over there. And there is one little branch that is called construction management. And that is the area that I belong to. And I'm going to try to tell all of you as engineers that what we are doing is necessary for construction management to improve and to do well. And what construction management does is also necessary for us to improve on the way of life, the quality of life of everybody in society. And when the quality of life of everybody in society has been improved, it is then that they can think of the power that they have. And when they think of the power that they have, it is then that they can take action. And so in a very long way, or in a very long-winded manner, I'm saying that the work we are doing is important to the construction industry. But what the construction industry does is important to empowering people, because it addresses their needs. It gives them the wherewithal. It gives them the strength and the possibility to take action. Okay. So this is the first slide of the summary. The next slide is this. I want to also try to explain to you what is the construction industry. All right, it's an industry that many people don't know about. It's an industry that is not very popular. It's an industry that many people try to run away from. Okay, so I want to also, we look at the year 2050. I want us to think about what India will need as it tries to get to the year 2050, and what you as engineers will then have to be faced with in trying to give India what it needs. All right. Now, in order for India to attain what it means that India must have a fantastic construction industry, very strong construction industry, which has the capabilities and the capacity to do what India needs. Okay, and these are issues that we will also address. And so my objectives are these. Firstly, I will explain to you what is the construction industry. Then I will also explore with you what the industry needs to do well. Then we will ask ourselves, where is India today in terms of its construction industry? All right. Then we will ask ourselves whether India is different from other countries. If you compare India with other countries, do we think India is doing well? Do we think India must do better? All right. Then the next one is how my industry, construction industry, can use the innovations that you make, okay, to do better in what it does. All right. And then I'm also asking you and I to think about how we can take the industry in India forward. So what is the construction industry? It has many, many definitions. It designs, it builds, it maintains, it operates, eventually it demolishes. And so this is what the construction industry does. And what does it design? It designs the things that are needed, like where we are sitting today. And those of you who are civil engineers understand it fully, but those of you who are civil engineers may actually not understand it. But what I'm trying to get you to understand is that we have an industry that is very important to the economy today. That is also very important to the economy tomorrow, because it is the one that builds the factories, it builds the airports, it builds the roads, it builds the harbors, it builds everything that we need in order to ensure our long-term development. So therefore, this is the industry that enables empowerment. That is the point I want to make. And also, I'm going to try to explain to you that what you do as engineers in all the branches that you have contributes to what the construction industry can do and do better, so that we together can also empower people. And this is my task today. Every country recognizes that it's an important industry, and it's a major player in the economy. In certain places, they have found it to be about 15%. It's a huge segment of the economy. But what is even more important is that the industry is the one that sets the base for economic development. All right. This is a report that comes out every year. It is done by the World Economic Forum. World Economic Forum asks itself how competitive countries are, and then it ranks the countries, okay, and then it asks itself which are the areas where there are difficulties for companies doing business. Now, one of the things that I always want to highlight is this idea about infrastructure. Australia, infrastructure is not a key point, but I'll be showing you some countries. And infrastructure is what my construction industry does. Infrastructure is what you as engineers can, through your research, ensure that the construction industry does better. Because it is one of the major segments of the economy. It is one of the things that we need for us to grow. This is China. In China, infrastructure is not a key point. It is actually very far down. Where are we? This is education. Oh, yes, this one here. The inadequate supply of infrastructure. That is the one that I'm trying to get to. Okay. But I'm surprised in China, it is a problem. It shouldn't be. Okay. And this is my country. In my country, it is. In my country, the inadequate supply of infrastructure is one of the factors. And this is India. Okay. In India, it is near the top as an issue. And this is where you and I, I'm hoping this is what you and I'm hoping will think about. How we can help India to improve on its competitiveness in terms of putting in place a set of infrastructure that enables the economy to grow well and do well and actually attract investment. Because investors look at this chart every year and they decide where to put their money. This is Singapore. Okay, so I'll leave you to have a look. And I think there's one more country coming. Oh, no, there's no country coming. But I wanted to also show you that industry is not just an important player in the economy on its own. It's also an important player in the economy for other parts of the economy as well. And so if you look at steel, for example, a big proportion of the steel that is made in India is used, or also even imported into India, is used in construction. Almost all the paint, almost all the glass, and so on. Okay? And so the economists will say the construction industry has what they call backward and forward linkage effects. What they're saying is that if construction is doing well, other sectors do well together, and they then move the industry, the economy forward. So if we have an industry that is thriving, this is one of the ways through which we can actually empower people by providing employment to them and leading them forward. It's not only India that thinks the industry is important. The next one, an example I'm showing you here is Ireland. If you know, if many of you know about Ireland, in the year 2008, they were hit, one of the most hardest hit by the big global economic and financial crisis. So it was Ireland, it was Greece, then it was Spain, then it was Portugal. 4 or 5 countries in Europe which were in big trouble. Now, Ireland is thinking that the construction industry can actually help it to move it forward and in trying to address its economic problems. I wanted to show you this. This is Scotland. Okay. Looking towards the future, they have a plan for addressing the construction industry and to move it forward. And this map here that they have shown, it's not in the paper, but later on I'll leave this with Lijo, and you can actually refer to it. But you can actually get the report. They are showing that the construction industry is actually bigger than what I'm even telling you. It goes beyond what I'm telling you. So it's a map that shows quite a lot about the construction industry. So the next one I'm asking is who else is involved in who's involved in the industry? So you have the architects who design, you have the engineers who also help in the design. You have the contractors who build, but you also have many, many different stakeholders. And what I'm also showing you here is that there are many people who are interested in what we do in the construction industry. So the stakeholder base, if you like, is very, very wide. Government takes action, government takes interest, government regulates, government facilitates, and government enables. Government is also a major client, like we would also say. All right? And then I like to look at the features of the construction industry. The first one is that it is highly, highly expensive. And therefore, we want to make sure that we get value for money, because it is the nation's savings going into these things, into the roads, into the bridges, into the airports, into the harbors. All right, and therefore we must make sure that we have the highest possible quality. That's number one. We must make sure that we don't waste people's money. The next one is the indivisibility of the items. Once we have started the construction, we must bring it to the very end and finish it. Otherwise, it is no use. You would have seen many uncompleted buildings around which you cannot use. And so it means we must be very sure that we can finish it before we start. And so planning about it, thinking about it before we start, being prepared, take it to the very end is important. So that is the idea about the indivisibility. It's not something we start today and finish tomorrow. When I was coming here this morning, I was discussing with Dr. Benny Raphael the fact that there are floods in certain countries and certain cities from year to year. Then you ask yourself, why isn't something being done about it? You can't do it tomorrow. It has to be planned. It has to be investment. It has to take quite a long period of time to do. All right. And so a project takes a long time. And therefore, it also, again, gives us the need to think about it before we start and to plan it so that it comes into fruition at the time that we need it. All right. The next point is that many people take part in it and many people do little parts of it because nobody can do it on their own. And because many people take part in it, many people do little parts of it, it means that it has to be managed carefully. And as it's being done, there's a lot of risk, there's a lot of uncertainty because the team A, taking what team A does something, team B takes it and works with it. Team B has no assurance that what team A is doing. Or let me put it another way. Team B has to have assurance that what team A has done is the best possible that can be done. This is where the idea of professionalism also comes in. All right. And as I go on, I'm asking you to also think about some of the points that I'm making in case you want to ask me questions. Because I've been told that I have time, and at one point I'll stop and I'll ask you to ask me questions. Or maybe I'll ask you questions. All right. The next point is the fact that the government is a major player. Some of the things that I mentioned, government is a regulator, facilitator, and investor on its own as well. All right. And the next point is the location specificity of the item. This is something that we can discuss later on if you are interested. And the final point is the fact that the item is something that we built and we want it to last. Okay. So we want it to be durable. We want it to last because it is the nation's savings. Every nation puts about 50% of their capital savings every year into development, into physical items that is made by my industry. And so what I'm saying is that we have an industry that must do the very best to ensure that people are getting value for the money that they invest. So those are the stages that we have. The client thinks about it. The client appoints someone to do the project. The client's, to design the project. The client then appoints a team through a procurement process and so on and so forth. So these are stages that all must take place before the project is realized. At the very end, the building must come down because it could have been 50 years, maybe 100 years, and we want to replace it with something else. All right, what we are saying is that we must also try and reuse, recycle, and think about how we use even the debris that we take down from the building as well. The point that I made earlier about the industry process involving many participants is important there. The industry being highly regulated is also important. From time to time, you hear of a building falling down. In many cases, after it has been investigated, we find that there were certain things that were not done as had been approved, as had been submitted to the government. And this is something that we cannot afford because of the loss of lives and also loss of many things. What about the industry in India? There is an agency called the Construction Industry Development Council, which I have known about for many years, all right? And they were formed by the Planning Commission and the industry, and they have certain objectives, they have certain vision. And so what I'm going to talk about the construction industry in India is from their website and from what they are saying, all right? They have that vision. So if you look at it, it's really fantastic, and they're trying to do the best that they can. And so what I want to urge you engineers is that the CIDC is waiting for your findings from your research. The CIDC is waiting to apply the findings from your research. The industry is waiting, but the CIDC says it is an enabler. It is a facilitator. If you like, it is the go-between between your industry if you don't have direct industry clients. Okay. The one on the left is one website I visited. But then also on the right is the planning document for India. And one of the chapters is on construction. It is not common to see a planning document with a plan for what to do about the construction industry. And so I was very impressed by that chapter 19. All right. Then having read it, I realized that it was written by the CIDC. And so that is what I'm going to tell you is that I'm not taking any information from others. I'm taking information only from the CIDC. So I'm telling you what the government says the industry should do. But the CIDC is only one of very, very few agencies like that. As I said, there are very few plans that highlight what needs to be done for the construction industry. Right? The CIDC is one of very few agencies like that which manage the construction industry. There's one in Hong Kong formed quite recently only. It's also called the Construction Industry Council. There is one in Kenya also formed quite recently. It's called the National Construction Council. And National Construction Council in Tanzania was the first one to be formed. It was formed in 1981, and so on and so forth. But the one in Singapore is called the Building and Construction Authority. That one is very strong, very good. It has done quite a lot of work. The one in South Africa is called the Construction Industry Development Board. It has also done some good work. And the one in Malaysia is also called the Construction Industry Development Board as well. I'm mentioning this to you because this is my area of research, and I've done work for many of these agencies as well. All right, and so the CIDC is saying some of the things that it has done to help the industry to grow. Okay, and then it takes trouble. That's chapter 19 that I showed you. It highlights the areas where it has taken action and what has actually happened. All right, and so we can say that something has been done or some action has been taken. It's a very long list, and a few more of the items are shown there. So then we asked ourselves whether it means that there are no problems. And I say there's no industry in the world which doesn't have problems. And in India, there are issues. And these are some of the issues that they highlight. All right, areas where they need to take more action. Work towards sustainable construction practices. Ensure that we have more precast construction. I'll be showing you some examples of this later on. And so on, they highlight a few areas where there needs to be more action. Okay, so I ask myself, because you are engineers, you may be asking yourselves about technology. Can we say that the construction industry in India doesn't need any more, if you like, push in terms of technology? And is it doing the best it can in the area of technology or not? And the CDC says no, it needs to do more. All right, and they highlight areas where more action is needed. And those are the 5 areas that they highlight. Risk mitigation is one that they mentioned. The next one is automation in design, automation in construction, automation in operation. They highlight that as well. Managing your assets properly using ICT, we shall be looking at that later on, is another thing that they highlight. Material science, materials engineering is another thing that they highlight. And the one at the top that they mentioned is sustainability and the science of building in such a way that the buildings are sound and safe and healthy. And it doesn't, they don't also have an effect, especially on those who are coming in future. Okay, so that their ability to meet their needs is not compromised by what we do today. Having said that, India needs to take action. Other countries also realize that they need to take action. This is the most recent review of the construction industry in the UK. And they highlight those 4 areas because these 4 areas actually capture many, many other big issues as well. All right? And these are areas where UK thinks it needs to improve. And every country believes that it needs to improve. This is Indonesia. Indonesia highlights their problems on the left-hand side, and they highlight their intentions on the right-hand side. So they want to go from the red to the yellow. Every country has some issues with what they want to do. And this is coming back to Scotland. Scotland also highlights areas that they need to address as well. So we go back to India. And I want to also impress upon you how we can empower people. Empowering people also means addressing some of the shortcomings in the industry. All right? And addressing some of the shortcomings can be attained also through some of the research that you're doing. Okay. They highlight all these. All right? At the same time, they say investment in research and development in India not enough. If investment is not enough, then it means we must try and make the very best out of what we are spending on the in the research and research and development as well. Okay, but what about going further into the future? Going further into the future, the situation will be even more difficult. There will be even more big areas that the industry should be addressing. All right, and some of those are highlighted there. The first one is the fact that I'm not sure about India, but in many countries, very few people want to work in construction. It is not popular. It is not attractive. All right, and so the industry struggles to get the very best to work in it. The next one is the fact that in future the projects are going to be more difficult, and we will need more help from engineers to design things that are, to enable us to actually attain what we want to do on the projects that we have. All right, and so on and so forth, and various areas that I think will also pose problems. Okay, and then from now on, what I'm going to share with you is how what engineers are doing will strengthen the construction industry and therefore enable the industry to empower our population. All right, we have an industry, my industry, the construction industry, which until now had been considered to be, some people use the expression, a technology laggard. It has been considered to be an industry that was not interested at all in improving technology. It has been considered to be an industry that is not interested in innovation, an industry that is not interested in high technology. There's a discussion among those who belong to my discussion group, the network that I belong to, construction researchers, and somebody was saying having a PhD, somebody started a discussion, having a PhD in construction is something that industry doesn't seem to want. And I'm asking why that should be the case. You can ask me a question on that and we'll highlight that as well. Quite interestingly then, the image seems to be changing very much. And so we have now an industry which it is said is going to, in future, be looking towards technology as its main driving force and as its main future. It was an industry that was looking at lowest cost. It was an industry that was looking at the cheapest way of doing things, all right? But it's going to be an industry that is going to be driven by technology, is what is being highlighted. And this is what is being highlighted in Australia. And I wanted to show you this photo. That in future, the workers that we will have in technology, in the construction industry will be workers who are extremely highly enabled by technology. Okay. There have been many attempts to try and look towards the future and see what the technology that we will need in the construction industry will look like. All right, it was done many years ago, and those of you from civil engineering will remember, if you have been looking, will remember those two exercises that were done in the US, okay, to try to address, to try to look forward toward the future. Okay, so many years ago, what they found was automation will be a key point. Next one, using materials not as they occurred naturally, but as they perhaps could have been scientifically understood and better done. Doing things underground and so on and so forth were things that were considered to be things of the future. All right. And those of you who are young and who have not seen this report, I would suggest to you to have a look. It was a report, a paper done, a very short paper, maybe about 6 pages only, in the Journal of the American Society of Civil Engineers. It was published many years ago by an engineer called Zook. This was 1988. It was looking towards 2000 and beyond. All right, he looked between 2000 and 3000, and he said there will be big changes and there will be big things that will happen in the construction industry. All right, I suggest that you have a look. In the paper, I give the whole, the whole series of projects that he highlighted. All right, if, for example, the first project he mentioned was that there will be a bridge between Alaska and Russia, and he mentioned that that will be between the year that will be in the year 2000. We can say there he was not right because it hasn't happened. All right, but what you can think of is that what he's saying is that it's possible if we put our minds to it to do things that are really fantastic. The next thing that he also said will happen was that there will be a huge earthquake in California, and this earthquake in 2009 will destroy many buildings, and the buildings will be rebuilt using robotics. This was 2009. It didn't happen. Robotics hasn't taken place, but he was predicting that if the robotics took place, then the Americans will move from their foot and inches and pounds to be using metric units as well. And that I found to be interesting. But he made many suggestions. For example, he suggested that there will be a bridge between Sicily and Italy. They're thinking about it, and I think they will do it, but it hasn't happened yet. Okay. He was saying all this because he thought technology will improve, materials will improve, and it will enable us to do all these. He went on to say a few more, and he said by the year 2099, there will be a building that is built completely and entirely of glass because of material science. Okay? And this building, he said, will be the showcase of an exhibition in Paris. Okay. So it's an engineer who was dreaming. And I'm hoping that all of us, as engineers, all the engineers here also dream. He was an engineer who was dreaming and thinking of the possible. He was an engineer who was dreaming and not thinking of what the difficulties were, but he was thinking of what could be done if we put our minds to it. He was thinking of what could be done if we really sought to innovate. He was thinking of he was thinking of the fact that there couldn't be any limits to what we could do if we really look forward and wanted to innovate. All right, this is the Building Construction Authority in Singapore that I highlighted to you. They were asking themselves what the technologies of the future would be. They were limited a little bit to looking only at the construction project. And those are some of the areas that I highlighted in terms of things that will be done. Okay, I'll go on and I will show you that what is then beginning to happen, especially today, is that they think we're talking about technology, very high levels of technology. I'm going to go through some of these a little bit. So we will talk about 3D printing, we'll talk about IoT, we'll talk about robotics, we'll talk about drones, and we'll talk about some, not the gaming engines, but big data as well. Okay, very quickly. Because they're saying that my industry, which used to be a technology laggard, which used to be very slow, which used to be extremely labor intensive, is now in an industry where it is thinking like Zook was thinking, and saying that change is the normal thing that we must actually have and that we currently have. And we are not afraid of changing. And we are actually going to make change happen. And we're going to do things anew, do things different, and so on. Okay. So these are drones. Drones today are very common. They're being used extensively in construction to do many things. All right. So in the paper, I described to you a study that is being done, or that was, I think, is finished by, this is a client agency, Crossrail. They built the biggest civil infrastructure project in Europe, just finished. And they were looking at how they were using drones. They were also looking at how drones could be used much further in future. So drones, if you like, they are the unmanned aerial vehicles, all right, which could be fitted with various things to help us to see things and to do things better. Okay, so some examples of how drones were being used are shown there. First one, because it's doing it aerially, it can tell us more. Next one, because it is doing things aerially, it can tell us where the dangerous portions of the work that we ourselves are doing actually are. The next one is that it can be used to inspect very tall things, so that we don't have people to go and do it, waste time, perhaps endanger themselves. The final one is that it informs us to plan better. Okay. And these are some examples. So this is like a drone. These are some examples. This is a site in California. They're using drones to monitor how people work and therefore to improve productivity. If you have that, then you don't need to have somebody there with a clock to try to measure what they're doing. I don't need this site. I need your help coming up. Otherwise, it will cause us problems. Okay. Yeah. Thank you. So we can do it remotely. Oh, this is fantastic. All right. So this is technology still. Okay. So there are other potential uses of drones. All right. And I'm saying that even now we have not used them to their to their potential yet. And so those of you who are doing research on drones, we in construction are waiting for you to do your research to enable us to move forward in improving what we do in construction in order for you and for us to empower people. Okay. The next one is 3D printing. You would have heard of 3D printing. All right. And I was showing you a bridge is a bridge across a small river in Amsterdam. Later on, I'll go and show you the picture. I was moving it here, but I think I might not have succeeded. They're using 3D printing. It's actually been done. The bridge has been done using 3D printing. And the suggestion is that the 3D printing is going to be used perhaps to build on planets, on the moon, and also on Mars. So if any of you here is doing research on 3D printing, we in construction are waiting because we think, and this research has shown, that it saves materials, it saves time, it saves cost. And work hard, help us to improve. Okay. There are some examples here. And this is what NASA, I tell you, is trying to do using 3D printing to actually build structures on the moon and on Mars as well. The next one is robotics. And robotics, very, very big issue. There have been many attempts to try to apply robots in construction. And it is only now coming to fruition. That is what I mean by the envelope now being pushed. People thinking that we can actually thinking that we can actually automate the entire construction process. This is the bridge, sorry. So I actually managed to bring it here. So this is the bridge. It's a bridge across a small canal in Amsterdam, built by 3D printing. And 3D printing, they use some robots also, right? The next area is materials. Many of you are working on material sciences. Again, I will encourage you, because in construction, remember, we say we use a lot of materials, all right? Get us the best. Get us materials that are not just telling us what we can do, but telling us what we couldn't even have imagined that we could do. All right? Look at the properties of materials. Build for us materials that are fantastic and that do better than what has ever been done before. All right? And this is what we are hoping that you'll be doing for us so that we can do better and improve what the construction industry does. One of my colleagues works on the area of nanomaterials. And nanomaterials, big thing. A big issue is whether they are environmentally safe, right? And so there's a bit about having to care. And so this idea of Zook, thinking that by the year 2099, there might be a building that is built completely, entirely of glass, all right? It's not far-fetched. It is possible using highly advanced technology to develop materials that have properties that enable them to be strong and able to actually cope with the kind of loading that you have on a complete building in that way. Okay, so these are the worries about nanoparticles, all right? And sorry. These are the predictions about the capabilities of nanoparticles. Okay, they would actually improve performance in very, very big way, but the worries about nanoparticles is the concern about their physical possibility that they might actually escape and cause illnesses in people during manufacture and also during the time that they've been used. Okay. But I will also end on materials by saying that we don't have to have the most advanced technology in materials. We can also find the best way of using natural materials as well. And this is also something that is going on. A lot of research going on. The Europeans are spending a lot of money on natural materials to try and see how best we can actually put them to big use. The next one, many of you are from IT, or many of you are from computers. Data management is a big thing. We have an industry that is very lazy when it comes to using data, all right? But disruption is already happening, and people are using data in a very, very big way and wanting to learn more from data, all right? So they talked today about the fourth industrial revolution, where what we are doing is actually bringing in the usage of data, in fact, sometimes to replace some of the things that we have been doing all the time. Okay, so this author is telling us that we can actually, by using data, improve on many of the things, improve on our prediction, improve on the things that we do, improve on the way that we do things in the construction industry. Okay, so data management is a big thing. But one area that we have always looked at is IT applications. All right, and I'll show you this thing. IT applications, it's showing as if it started from zero, But today we are here. Sorry, we are here. We're talking about application of building information modeling. And my colleague, Dr. Benny Raphael, is an expert in this. Okay. I'm not sure whether Benny is talking about computer-aided design. No. Okay. He says no, but you talk to him during the break, all right? Because he's an expert in computer applications. And I will tell you about his, oh, sorry. So I was going to say that many countries are looking at building information modeling, right? The use of information technology, information and communication technology in the biggest possible way in the construction industry to improve on what we are doing, all right? Many countries are making it compulsory. In Singapore today, if you want to submit your drawings for approval before you build, it must be in the 3D format using BIM. In the UK, the government has a strategy for attaining it. So in Singapore, they have a BIM master plan. In the UK, they have a BIM strategy, which I'll be showing you in a minute. All right. So in the UK, it's mandatory for public buildings. In Singapore, it's mandatory for all buildings. So this is the UK strategy for attaining building information modeling in the UK. And this is the Danish government. Every government in the industrialized countries have actually realized the need for BIM and is pushing towards making it, taking the best advantage of it, from it as well. Okay. But a colleague of Benny's, he was looking at how information and communication technology could be used in developing countries. All right, so he looked at many of these big topics, and he highlighted some areas, especially for developing countries. Those of you who are doing IT will recognize this. Now, the point I'm making, and the point I've been making all along, is that we have an industry, my industry, which was very much afraid of technology. Now, today, we say we're no longer afraid of technology. We want technology to be our future. We want our future to be driven by technology. And we are requesting you as engineers to help us to attain this future. And therefore, in your research, whether or not it is directly related to construction, ask yourself, how can you help the construction industry to do what it is doing better? Because I think it is through construction that we can really empower the population. Okay, so that is my point. I'll go on. So this is a group of companies in the US. All right, they call themselves Fiatech. It's a group of building owners, and they were looking at how IT could be applied, and they formulated this map. And this was the map that Benny's colleague, Koshi Varghese, used to try to see the future in terms of IT application in developing countries. Okay. So there's no need to say that this is only something that is possible in the industrialized or so-called developed countries. There's every need to say that this is something that we should also do. And that is what Koshi said we could do as well in developing countries like India. So this plan was made in the US, but he said there's no need, there's no reason why we couldn't also use what they were proposing in our countries as well. Okay, and so I'm saying that when we talk about information communication technology, perhaps the future is already here. And today we are using GPS, we are using satellite information in a fantastic way to do many, many things. We are using RFID also in many, many big ways to do many things. All right, we're using lots of high-tech applications. All right, and here we talk about IoT, or the Internet of Things, and this is one example. It is enabling companies to do lots of big things. And so also don't say that we have an industry that is not interested in what we're doing. We have an industry that is interested in the most advanced technologies that we're working on. All right, and therefore my industry is today waiting to get the very best and the most advanced from your research as well. For an example is this one. Remember, in construction, because of safety reasons, we wear helmets on site. All right. And so the question that people have been asking, why don't we equip this helmet with certain features, certain facilities that enable us to improve on what we are doing, all right, and to do better. And so there is some smart methods that have been built into helmets. Okay. So here it tells you many things that this helmet does, and I will not go into detail, but later on look at the paper and have a look. This is how the helmet looks. So it is equipped with so-called 360-degree capability. Person can actually see into great, to a big extent what the person is doing. All right. It says also that you can actually send information to this person, give instructions to the person, while the person is away from where the supervisor is. Okay. You can see it on the screen on the side of what he's wearing. And something that we have also been always wanting to do in construction is try to, prefabricate things, make things as if they were being done, or do the work we are doing as if we were working in a factory. All right, prefabrication is something that is a little bit old, but it is being pushed to a very big extent. All right, today we are building, we are prefabricating, we're manufacturing, we are making big buildings, not just parts of buildings. So we're trying to move from here, where we pour wet concrete, to a situation like this one here, where a building is being manufactured. And this is what he's telling you, that in future, your building will not be built, it will not be made, it will actually be manufactured. All right, and this is by that person there, and it's from that website. So later on, you can have a look. So it was a building that was built in the period that they're showing, 19 days, 57 stories, and this is how the building was looking like. This is how the building was put together from packages, and this is how the building, after it was finished, looked like. And it is possible. And the work that you're doing as engineers is what we are waiting for to enable us to do things like this. Increasingly, what is being done is that there is more and more of even sophistication in this manufacturing, prefabrication, all right? So that the suggestion is that perhaps in future, there will be small micro factories sitting beside buildings, sitting beside building sites, making the items for the site, all right? And this example that I give in the paper is a house that is being manufactured and being used. Not very expensive. It's actually done as a whole. It takes a very short time to go and put it up. And many people think that this is a solution for the homeless situation in many European countries. But what, so then when you look at the future, you ask yourself, what are some of the issues that you should be thinking of? And there have been many people who have thought very hard and very fast about this, all right? And they have made certain predictions. And these are some of the predictions. So what can we have in future? In future, we will have a situation where we have perhaps the best possible technology if you engineers work very hard and give us the technology, for which we can apply across the board in all possible areas. So Fiatech has put up this thing here. It's very interesting, but a bit too long to look at, and I'll urge you to have a look in the paper. The company that made the helmet that I was showing you says that in 10 years' time, we'll be using augmented reality, visualizing what we are building in 3D format, and so on and so forth, applying it to the entire production pipeline. All right? That we will know where every item of equipment actually is. This is actually a big problem where we have big sites, like road construction projects. And we would make sure that we would actually know how well the equipment is doing because of how the kind of sensors that we apply to it and how we're working upon it. All right? So that is when we look at the future in terms of technology. But when we look at the future in a bigger way, all right, then we find that technology is not the only thing. For example, the World Economic Forum, they set up a group. World Economic Forum, remember, is every year they have this meeting in Davos. Right, but it's also an existing organization. It's set up a group across the economy to look at the future of construction. And they looked at the future and they proposed many things. Those are the objectives they highlighted, all right? But in terms of construction, they said it will be driven by these 4 things. First one, technology, what we are looking at, what you are working on in your research. They said it will also be driven by urbanization. They said it will be driven by the fact that we need to be more sustainable in what we do across the board. And the final one is that our projects will be bigger, more complex, more difficult to do, more expensive, take longer, and therefore, there's the need to try and see how to do them better, make them, well, not cheaper, but, in the most cost competitive way. All right? Then they highlighted these things that need to be done. 8 areas, all right? The first one, they said technology, materials, and tools. The next one, processes and operations, strategy, and so on and so forth. All right. Now, what I just wanted to say is that they looked at this one here. And then under that one, they highlighted these. And these are what I think many of you are actually working on here. All right. Many of them, I say, are among the topics that are being discussed here. Okay. Now, these are the 8 areas that they highlighted. Right. The first one was this. Second one was that. Third one was that. Fourth one, fifth, sixth, fifth one. So you see regulations coming in. You will see the need for collaboration coming in. You see the need for industry working together to let people know what they're doing, like me here telling you what to do, what people are telling you what the industry does. And then we'll see the fact that we need to address people. And so what we are saying is that it is not only technology that we have to look forward into the future to try to picture, to try to visualize, but we must look forward into the future to look at the entire industry. When we do that, we say that technology is very important, but it is only one. There are other areas. And the World Economic Forum's group, they found 7 other areas. All right. And therefore, our industry, which has been typecast as being very slow to adapt, slow to innovate, very resistant to change, very old technology oriented, very low tech oriented, all right, is now saying that its future lies in technology. At the same time, it is also saying that it must look at many other areas as well. Now, the question is, which are these other areas, and how does technology then come in to try to help also these other areas as well? And that is what I want to finish with. So there are a few proposals that some people have made, and I wanted to show you this. This was a study done by a group in the UK. All right, and they think in future, these are the so-called rising stars in the construction industry. But in future also, these are some of the threats. These are the people they spoke to, and this was over the next 12 months. But I'm not interested in this. I'm more interested in this one here. And this may be some of the areas that many of you are doing your research in. All right. And so this is also a picture of a construction industry that is looking forward towards a technology-driven industry. Okay. But even in order to apply any single technology, you must know what this technology does. You must know how to get the value for money from the technology that you are applying. You must know how to make sure that the whole organization moves forward by applying this technology as well. Okay. But I think technology can really improve what we are doing. And I'm coming to the end. So there's this organization in the US, the Construction Industry Institute. It's a grouping of construction companies, all right, which then sponsors studies, sponsors research. And they said in future, currently, these are what companies are doing. And the companies that are doing well, these are the things that they're doing. They're looking forward, preparing their work packages by planning ahead, if you like. Okay. Being careful that the projects are very well prepared before they go onto site, and so on. So they highlighted many of these areas. Many of these areas, I hope, are also things that you're currently doing. What I'm telling you is that these are some of the things that my industry is waiting for you to do in order to help them to improve. So I just put together some photos to interest you. One of the things that I thought was interesting is that today we're talking about very tall buildings built with timber. Tall buildings built with timber because of the technology, because of the material science that has gone into the timber to do so. They're actually talking about an 80-story building in the UK built of timber. So, all right. So many examples of what we can do in future. So these are some of the things that we talk about: robotization, 3D printing, and data management. This slide is, I think, my last but one. This is from NUS. It is showing that no single person, no single group, no single company, no single organization can actually bring all of us forward in terms of improving the construction industry, right? In terms of improving what we are doing in the construction industry, in terms of enabling my industry to contribute towards empowering people, no one can do it alone. It is a consortium effort. I like this slide. I don't have permission to show it, and so I'm only just showing it to you. So I have to delete it from what I leave with you because I haven't sought permission yet. But this was something done by my university. So you see some companies, you see some, but all of them actually highlighting areas that they could perhaps contribute towards making it possible that we move the industry forward. So this is my last slide, and I'm going to say that this is what I've highlighted. But what I'm hoping, that is what I've made clear, that the topics that we are discussing here at this colloquium are very important. If we're talking about empowering people through technology, all right? Especially when it comes to construction, the topics are very important. And in construction, we are waiting for you to do your research so that we can contribute towards empowering people. But the question is, as I showed just now, no single area is the most important. No single area can do it alone. We must bring together many areas. And the bringing together is a challenge. The bringing together is a challenge. The respect for others, the respect, the appreciation of what others do, the knowledge that what we are doing is not alone, it's not enough, we're not alone, we're working with others. The humility to accept that we can't do it alone. The ability to integrate what others do with what we do. The willingness to be part of a team. I can go on and on and on. But what I'm talking about then is that we must understand ourselves, understand each other, try to look at the work we are doing, see how the work we are doing actually fits into what others are doing, because it is only through then that we can integrate. It may not be us integrating. We don't also have to claim that it has to be us integrating. Others may have to integrate, all right, and move knowledge forward, move technology forward, and move society forward, and empower people in the end, all right? And having said that, then, we will see that this ability comes not from knowing the technology, it comes also from knowing human behavior. It comes also from knowing organization behavior. So it comes also from knowing both the hard things and also the soft things as well. All right? And therefore, I'm saying that we who educate engineers must also educate them on the soft skills, must also educate them on, I use the word humility, must also educate them about knowing themselves, must also educate them about knowing other people, must educate them about appreciating other people, educate them about teamwork, educate them about having respect for other people's cultures, and so on and so forth. The idea of leadership, the idea of, a word that I use and I like to use is the word professionalism. The idea of professionalism is key. And so as we teach engineers to become very, very much better engineers, we must also teach them to become professionals. And I think if I'm a professional doing what I want to be done, I can actually go to sleep if I know he's a professional. But if he's only claiming, or she is only claiming to be professional, but it's not, then I have every reason to worry. And therefore, I'm glad that your project director actually was head of the entire society of engineers, technical officers, engineers in India. And so I think this discipline, this orientation, this appreciation will be spread to the students here. But those who have come from elsewhere, I'm going to hope that we all go away from here recognizing that what we are doing is important. But what we are doing is not the only thing. What we are doing is part of billions of other things. What we are doing must be subjected to application. And what we are doing must be subjected to integration with others. And we must have the ability to appreciate all these things. I'll just finish by saying that if we're doing it then for the construction industry, then we need a plan. And the plan, like what the UK did that I showed you, like what Scotland did that I showed you, like what Malaysia has just done, they're looking at the year 2016 to 2020, they formulated a plan for developing the construction industry. I looked on the website for the construction industry development plan for India, or strategy for India, and I have not found it. And we do need a plan. But I'll leave you with that. And so the point that I'm making is that education has a role to play, but each of us must want to be a professional. Each of us must want to do what we can to empower those in our society. And I wish you all the best, and I hope you have a very good conference. Thank you. So now I must ask Dr. Paul whether I have more time or, okay? He says yes. So he says you must ask me questions. Is there anyone who wants to ask me a question? Anyone?
Yeah, I think many of the problems in India are not because of bad engineering or because we don't have the technology. So I agree with you very well that we need something beyond technology. I think a lot of the problems are because of institutional and organizational issues. Okay. One example I can quote is the use of prefabrication. We know that it's going to speed up construction a lot, and we can make the construction industry as efficient as the manufacturing industry. But people don't do it for one reason, because the moment you do prefabrication, it's treated as a product, and there are some tax issues. You have to pay tax something like 20%, okay, which eats into the profit. So companies are not going to do it because it's not profitable anymore. And this issue, I've heard my colleagues in the process of and Koshi talk about it almost 10 years ago. So it's an issue which is well recognized, yes, but nobody is paying any attention to it. So we are talking about a decade of lost productivity. That's because right. of institutional problems. So okay. I think it is just, it's more than technology. It is the mindset of people, or maybe even cultural issues.
Okay. Yeah, all right. Well, Benny was my colleague in Singapore. So I'm glad he's made a comment. He's not asking me a question, but I'll take his point and I'll go on. And I'll be visiting his university when we finish from here. And I will make a presentation there, and we'll do a workshop after that. And so later on, ask him what happened at the workshop. Okay? Because we will explore some of these issues into a bit more detail. The point that he's making is appropriate. And this is, it actually strikes a chord with me just now, because I've just finished a study for the Singapore Contractors Association Limited, looking at how to improve productivity. One of the things is the fact that once you bring in a new method, you make an old method obsolete. Now, the old method that you have made obsolete, there are many people who perhaps will lose their jobs or are losing their business. So you must actually have a comprehensive plan for going forward into the future, and not making victims of those who are going to find it difficult to keep up with what is being done. And so the point he's making is also the fact that we need to look beyond the technology to look at how the institutions actually work, to look at perhaps providing incentives, to look at encouraging the client to be willing to pay a little bit more, and so on and so forth. And so not giving the impression that what we're going to do is cheap, but giving the impression that what we're going to do is better for all of us is what we should do. Yeah. There's one issue about the industry's image that I have not yet highlighted. Well, I did highlight it. I said the industry is not popular in many places. Many people are seeing things like prefabrication. Many people are seeing things like high-tech approaches to construction as a way of the industry improving its image, maybe being able to attract better people into it. Yeah. Okay. Other questions?
Sir, I would like to know the 3D printing you have mentioned. Once you make that bridge that you are told, yes, will it have enough strength, enough like an ordinary bridge so that people can walk or something like that? Is it possible?
Well, so this is a question I asked myself. So if it wasn't possible, then because it had to be submitted for approval by the authority, so it's an approved bridge for use. It's not a model. It's actually a pedestrian bridge. Yeah. But you can actually Google it. You know, the 3D model, the 3D bridge across, I think it's a canal in Amsterdam. Yeah, it's the city. And you find people standing there to watch. But I think you're quite right. I don't know, maybe they are not so bold to walk across it, perhaps thinking that it's not strong enough. But we're talking about is actually the 3D. It's actually being used to build houses. And there are 5-story houses that have been built with 3D printing. Yeah. But I'm not an expert on 3D printing. As I said, I'm not an expert in technology, but I take interest in it. My interest is to see how technology can improve what we do in construction. Yeah. Other questions? I want the students to ask questions. Any student here? Okay, I want the conference participants to ask questions then. No. Okay, yes. Yes.
Buildings and construction.
I have a whole lecture on it.
Thank you.
You have 2 days. I can tell you about it. Yes. Okay. So sustainable construction is what I work on. I actually say we should stop talking about green construction, talk about sustainable construction, because sustainability has 3 elements: it's society, environment, and economy. All right. They actually talk about 4 institutions as well. So the word corruption, for example, is something that I want us to also look at as well. We talk about sustainability. So sustainable construction is something that I've been very much interested in, and I've done quite a lot of research on. So you have a good point. We must push and not move towards, but move along on sustainable construction. And many countries actually have realized this, and Singapore they have now their 3rd green building master plan, which means they have already had 2. In Singapore, it is compulsory to meet certain minimum standards. And minimum standards are very high in terms of green performance in the building. Yeah. And Singapore has made it a requirement also. Even when the building is already standing, if you want to upgrade it, you must meet certain green requirements. Yeah. I don't know about India. I know there are certain standards that are applied, favored by the developers, the owners, that are being used, but I'm not sure whether it is compulsory yet. But many countries have realized this, and they are moving along towards it. UK, unfortunately, goes forward and comes back. So I cannot use it as an example. The small country, Singapore, in this particular area, I can use as an example. Yeah. Okay. Anything else, Dr. Cherian, that you want to ask?
You mentioned about composite materials. Being composite materials.
Yes.
So you being pioneers in composite materials, RCC is a composite material, isn't it? So reinforced cement, concrete is a composite material.
Yeah, that's right.
So what kind of new composite materials are you, trying to use in the construction industry?
Okay. Again, I'm not an expert in material sciences, but I like this expression that I read a very long time ago in the 1990s, where it was saying that we are not just studying the materials, all right, and trying to find how we can use the materials that exist, but we're actually studying we are determining the features of materials that we need, and therefore trying to design the materials to do these things for us. So there are many composite materials, sometimes made of 2 different metals, where we try to take certain characteristics and properties of one to balance the characteristics and properties of another, and so on. Okay. In terms of construction, I'm not sure exactly which particular materials are being used, but there are many composites that are being done. Sometimes they're also trying to see whether they can actually marry plastics with others as well. Plastics being married with metals is something that they're currently doing a lot of research on. But there's something that is interesting. It's still timber, but the cross-laminated timber is something, is something that they think gives it more strength. And so the 8-story building, for example, is one that has those kinds of features. Yeah. But these days, I get a lot of information from the internet. And so if you like, just say composite materials construction, and there will be many examples for you. Yeah. All right. So for me, the task is how we can use these materials to the best possible advantage in the construction industry. So I'm hoping that researchers have already found the materials, and I'm asking myself, how can we benefit? I hope I've answered your question. Yes. Okay. Any other questions? Okay. Otherwise, I'll tell Dr. Paul that I finished. Yeah. Thank you very much for your attention.
Thank you, sir, for the talk on how we as researchers can contribute for empowerment through technology for a better future. I would like to request Professor Ofori to kindly release the conference proceeding of Raerest 2016. And I invite our project director, Dr. PJ George, to receive the first copy of the conference proceeding from Professor George Ofori. As a token of love and gratitude, I request now Reverend Father Jose Tarpel, Balsar of SJCT, to please present the Aranmulla Kannadi to Dr. George Ofori. I also request our project director of our college, Dr. PJ George, to present the memento to Professor Ofori. This memento was designed by Mr. Renju Rajan, staff of Civil Engineering Department of our college.
Thank you very much.
Thank you, sir.
Thank you.
I now invite Dr. George Tom Vargas, Associate Professor, Department of ECE, to propose the vote of thanks.
Respected dignitaries of the dais, Honorable Chief Guest, Dr. George Ofori, the century we live in is the century of science and technology. To a certain extent, they dictate the language we speak, and we are left with no other options other than to use that language or remain mute. This realization has evoked a wide range of emotion around the globe. Some view it as the ultimate evil that deprives us of our humanity to dog us to the ultimate doom. Some others view science and technology as an improved means to unify the world to help remedy some of the mammoth challenges humanity faces today. It is with this view, St. Joseph's College of Engineering and Technology is organizing its first global colloquium on recent advancements and effectual researches in engineering, science, and technology. As we have come to the end of an enriching, inspiring, and thought-provoking session, I feel privileged to express our heartfelt gratitude to our eminent resource person, a conscientious teacher, a committed researcher and a scholar par excellence, Dr. George Ofori from the National University of Singapore. Moving in line with the theme of this conference, human empowerment through technology, Dr. George Ofori has skillfully guided us through the field of construction management with a special emphasis on the need and means to empower the Indian populace through improved performance in the construction sector. As Dr. Ofori has pointed out, this session is intended to add something to the efforts and initiatives already been taken to improve the standard of living and quality of life of our population by enabling the construction industry to improve its efficiency and effectiveness through the application of possibilities of science and technology. What we lack in is the comprehensive planning to help the industry meet its task it should accomplish to improve the quality of living here in India. This calls for a brilliant combination of hard and soft skills. What we really need is a handful of skilled people, that means scientists and engineers. As Dr. Ofori puts it, soft skills under motivation, professionalism have to be developed among scientists and engineers. Let's respond to this call. Dr. Ofori, we deem it as our proud privilege to have you here amidst us this day. We wholeheartedly thank you for coming over here, enriching us and inspiring us to think further, to toil our hands and brains to improve the living condition of the people of India by exploiting the possibilities that science and technology offers. Thank you, sir. I use this opportunity to thank all the delegates, research scholars, my colleagues, especially Dr. Lijo Paul, and students gathered over here. Thanking you all. Thank you.
Thank you, sir. I request all the participants to kindly go to their respective venues. The Applied Electronics and Instrumentation Department will have their session on ECE Lab 3. Civil Department will have 2 sessions, keynote addresses at PB4, Conference Room 3 and Conference Room 2. The Computer Science Department will have a keynote. Electronics Department will have one session at ECE Lab 1 and the second section at ECE Lab 2. The AAA Department will have a keynote address at DB4, Conference Room 4. The Mechanical Department will have a keynote session at the main block seminar hall. I now invite you all to join for the tea that is arranged outside the seminar hall. Have a great day.
Good morning, ladies and gentlemen. I invite the eminent guest, Dr. Ansman Basu, Ms. Smita Jacob, and Dr. S. Balakrishnan onto the dais. Welcome to Raerest, recent advancements and effectual researches in engineering, science, and technology. We are very much proud and honored to host the first international colloquium at St. Joseph's College of Engineering and Technology, Pale. To welcome the gathering, I invite Ms. Smita Jacob, Head of Computer Science Department.
Most respected keynote speaker, Dr. Anirban Basu, President of Computer Society of India. Respected delegates, HODs, invited guests, colleagues, and my dear students. A very good morning to one and all. Raerest 16, the International Conference on Recent Advancement on Effectual Researches in Engineering, Science and Technology, with the foremost objective of bringing academicians and researchers around the world to share and learn from each other. The theme of the conference is Human Empowerment Through Technology. The international conference is an effective effort of 6 engineering departments of SJCT. The Computer Science and Engineering branch has received 6 research papers and 30 quality peer-reviewed papers are selected for the final presentation. About the department, the Computer Science and Engineering department of this college has always been in the forefront, promoting technical and adaptive learning. The department offers undergraduate and postgraduate programs in computer science and engineering stream and has always enjoyed the presence of eminent faculties and student prodigies. The department has always promoted golden opportunities for techie students, providing them with financial support and technical expertise. To name a few in the list, our students won first prize in NASCOM Startup 2020 competition, third prize in international level robotic competition, and first prize in Best Idea Presentation Hackathon event. Over the years, the Computer Science and Engineering Association, IEEE Computer Society, and Computer Science and Engineering chapter of the college has jointly organized a variety of national level competitions, funded workshops, technical workshops, hands-on training program for the students. It is my pleasure to let you know that the CSI student branch of the college has obtained Certificate of Institutional Accreditation, and all the students of Computer Science and Engineering branch are the registered members of CSI. The CSI is the largest and oldest body of IT professionals in India. We are very privileged and honored by the presence of Dr. Anirban Basu, the President of Computer Society of India. He has more than 35 years of experience in advanced research, development, commercial software industry, consultancy, and corporate training. He has been serving CSI in various capacities and was serving as the Vice President of CSI for the past year. He is here with us to deliver the keynote talk on challenges in software quality engineering. On behalf of the CSE department and all the entire gathering, I welcome Dr. Anirban Basu to this interesting section. We have with us today the representatives from universities, research organizations, and industries. I believe this conference provides an opportunity for sharing the knowledge and research finding of eminent and experienced professionals from different verticals. I would also like to welcome the participants and students from various engineering colleges in and outside Kerala. Welcome to you all. Next, a warm word of welcome to all the invited guests, faculties, and my dear students, those who are attending the keynote session. Welcome you all. Finally, I would like to thank my organizing team and the student volunteers for their untiring efforts to make this conference a memorable one. With these words, I am confident that this conference will create a forum to exchange scientific ideas and will enrich the students' technical excellence. May I wish you all the very best. Enjoy the 2 days of technical excellence. Experience the Raerest. Thank you all.
Thank you, ma'am. Dr. Anirban Basu secured his PhD in computer science and has more than 30 years of experience in academia. Currently serving as the president of CSI, he is a recipient of a number of awards and a member of various computer science societies. One among to play a key role in design and development of India's first supercomputer Param. His contributions to the world of computer science are worth to be praised. Without much more introduction, I wholeheartedly welcome you, sir, for the keynote address.
Good morning, everybody. I must thank St. Jesus College of Engineering, especially Dr. Smita Joseph and Dr. Balakrishna for inviting me here. In fact, I had met Dr. Balakrishna about 1 year back when he was in Salem. So he remembered that and invited me. So I'm happy to be here. I believe there is a CSI student branch also here, but I have not met so far anybody from there. I hope they're active. So let's see. I'm going to meet up, and one of my objectives of coming here is that obviously to see the growth of CSI, Computer Society of India. Anyway, so I've I've got a variety of experience right from the academics. I started my career with the Indian Statistical Institute, Calcutta. Then I was with CDAC Param project, and I was with the commercial IT industries like Siemens and a couple of other companies. And I still consult with different companies and get involved in corporate training. So I know what happened. I am also involved in teaching in the postgraduate and research, guide some PhD students in different areas, primarily in software engineering, cloud computing, green computing, and all these things. So I know exactly what is. I'll just go back to start from the beginning. So I know what is happening in this. I don't need this. I can operate with here. I said, give me that book. So I know exactly what is happening in the academic institutions because I am connected with both academics as well as industry presently. So I thought that there is a need to bridge the gap. I think one of the most important areas and most important subject, which will all now, because I think most of you are students and going to join some IT company. I think most of you are students and some are faculty members. That's what I guess. I don't know if anybody is in the industry. Anyway, so for the students and anybody else, the most important subject which will going to be throughout your life will be there with you is software engineering. And this is one of the subjects which is, I think in all syllabus it is there. Pressman's book is there, Somerville's book is there. But I think it does not, somehow it does not, people don't understand, assimilate the knowledge which is all in the books. See, I think it is too much of theoretical subject, but it's a very interesting subject and it's a lot of practical experience. So I chose this topic and I've recently written a book on software quality assurance testing and metrics published by Prentice Hall. The industry people as well as academic people are taking this book because academic people, it helps them to get jobs because it's very practical oriented, and the industry people still have to learn a lot of theoretical concepts. So there's a need to grab the requirements of both. Industry people are lacking theoretical concepts to some extent, and academic people, the student community are lacking the concepts which are needed to get a job or just start in your career. What are the things which is required? A lot of these things are not included in the university syllabus. So one of the most important things is the software quality. So quality is a very difficult term to, so I chose this topic to discuss here. So there have been several historic disasters, and these have been attributed to the software failures. Like in 1988, the shooting down of Airbus 320 was due to cryptic and misleading output. Similarly, 1991 Patriot missile, then 9-hour breakdown of AT&T's long-distance telephone network was caused by an untested code patch. As you are seeing, this is nothing, even in your operating system, which are Windows and all these things, you will see a lot of patches come, updates are happening. So obviously the updates are happening because there were some bugs which have been found out, and Microsoft is trying to give you a patch so that you can correct those things. So it is not easy to develop and deliver very high quality software and highly reliable software. This is one of the most interesting, more important challenges which is facing in the software community. Now I am starting from the beginnings. Now who cares for quality? When you tell me who is a customer, can you define who is a customer? I start from the basics so that our basics, if they are right, then we have easy time ahead. So who is a customer? Huh? No, buying and using it is an user, because Microsoft has users of millions of people. But for Infosys, if Microsoft is giving them some work, for Infosys, Microsoft is the customer. The person who pays for it, of course, for the shopkeeper, for the distributor, obviously the user is the customer. But in the case of large companies, the customer is normally the people who are paying for the services. If GE is paying for developing some software to say TCS or something, then GE is the customer for TCS for that project. Anyway, there are two different things. One is the customer and the users, and both have to be satisfied about the quality. But their quality requirements are different. Now, Japanese, Japanese are very finicky about quality. If you talk about quality in any part of the world, any product, I think the first name which comes is Japanese. If you want to buy a camera, you will go for a Canon or something. If you want to buy a car, probably Honda is one of the good options. So Japanese are actually, whenever we talk about Japanese products, we more or less expect a very high quality. And a Japanese scientist called Kano studied the quality behavior, the expectations, customer expectations. and he found out there are three types of behavior which customers normally expect. Now, suppose you go to a hotel so wherever in Kumarakam and find that there is no water in the tap in the hotel. So what will you do? Will you be going to the manager and complaining? Isn't it? You'll be going to the manager and say why there is no water in the tap, isn't it? These are some requirements which are expected, implicit requirements. You don't, when you book the hotel with 500 rupees or 1000 rupees or whatever it is, you never told that yes, there has to be water in the tap. But these are expected requirements. But if it is violated, then definitely you're going to scream, isn't it? Suppose I buy a TV and you bring it home and it doesn't work, then obviously you will not be too happy. You will definitely go back to the customer, to the shopkeeper and say that yes, what is this TV you sold? This doesn't work. But if the TV works, will you go back to the shopkeeper? No, isn't it? Because there is no, you expect that it will work. This is what is, unless it's violated, some basic requirements have to be met. Then customers don't speak, isn't it? The same thing. But if it is, if it does not met, then obviously customers will shout and come back to you, isn't it? Margaret Thatcher had said that if the product is bad, then it will come back. But if the product is good, then the customer will come back, isn't it? It's very true. Now, if there is another type of customer behavior. Now, suppose when you went to buy a TV, unexpectedly you found that the shopkeeper is giving you a mobile phone free. So what happens? You get excited, isn't it? Then what will you do? You will tell all your friends that you buy a TV from this shop in what is the nearest place here? Whatever it is, in Kottayam or something, and you go to that shop because they're giving a mobile free, isn't it? So they're excited. So you will definitely get excited and it will. So whenever you are developing any product, same thing when you join a company or something like that, you should, whenever you are studying also, like Smita ji has given you an assignment, you should try to excite her. You should do it so well that she will say, yes, really it's good. You are a really great student. So we should always try to excite the customer. That is most important. When you talk about quality, you have to try to excite the customer. That's important. Then he will say, yes, this is quality. So now coming to what is quality. Now defining software quality is a bit difficult. Now am I going fast or is it okay? Okay. So now conformity specifications. Who gives the specifications? Obviously customer, isn't it? And how does the customer get the specifications? From the users, isn't it? Then if I differentiate between customer and users, then obviously customer has to know what the market wants. Accordingly, he will to compile all the requirements and give it to somebody who is going to develop the software. I am talking in terms of the software industry, not in terms of any other industry. And then obviously you have to meet customer needs. Customer needs in terms of the time, quality, everything, isn't it? Now the multi-dimension, but then software quality, as I said, that the different customer wants something, user wants something. We'll see that developer wants something. So there is different multi-dimension nature of software quality. Software quality is a very difficult term to define. Quality is generally a difficult term to define in any respect. Even in the building in construction, and it's not easy to define what is quality. So multi-dimension nature of software quality, and different people have tried to define software quality in different ways. And then there has been McCall model, Boehm model. I think you might have seen some of these models in your textbooks. And then ISO is the International Organization for Standardization, which is based in Geneva. You have heard about ISO 9000, ISO 25000, ISO 27000. So many things have been defined. ISO defines standards for everything. So ISO has come out with a standard for software quality. They say software quality can be defined in terms of functionality, reliability, usability, efficiency, maintainability, portability. These are the 6 factors which is defined software quality, which are defined for the user, for the customer. These are the things which are important. What is that? He will check whether the software meets the functional requirements. You know what is functional requirements? You know, requirements can be functional as well as non-functional. What is a functional requirement? It should do the functions. Like if you're buying a pen, it should be able to write, isn't it? That's a basic function. Then there can be other functions for a fountain pen, or a ball pen. The functions will be different. The functional requirements, it should do the functionality. Reliability, obviously, it has to be reliable. It should not break down as soon as you buy it or after some. It should be reliable, means it should work for at least a few months, a few years, or hundreds of years, whatever it is. Usable, yes, it should be easy to use. Efficiency, what is efficiency? Efficiency means the resources used should be less. Now, suppose you have bought a software and then you find that once you run the software in your machine, it takes about 20 GB hard disk, 4 GB RAM. Will you be too happy? And no other application can run on that. When you start running that application, obviously it is taking so much resource that no other application will be able to run. So that is not efficiency, isn't it? Because you want to solve a lot of other applications. It should be sleek. It should take less RAM, less resource. That is what is important. So efficiency is important, and maintainability. It should be easy to maintain, and it should be portable. Now today the software is developed on Windows. Tomorrow it should be portable on the Linux, isn't it? Or Windows 7. Now today it is. Yesterday it was Windows XP. Tomorrow it may be Windows 10. So it should be portable. That's what you want. So there are 6 factors which contribute to software quality: functionality, reliability, usability, efficiency, maintainability, and portability. These are the important. So if they ask in the interview that what is software quality, these are the 6 parameters which can help you in defining software quality. But then question is that now for a user, for the user, he may not be interested in those things. But what is the user? So suppose you have bought some software. For a user, he is interested in effectiveness. Now you have bought an accounting package. He will see how effective it is to use in his office, isn't it? Whether it is doing the calculation he wants. So that is effectiveness. Productivity. Is it really improving the productivity of the people or the accountants? Suppose they were taking 10 hours for doing some accounting practice. Now is it taking 4 hours or 2 hours or 3 hours or 10 hours or whatever it is, or taking more. Then is that productivity is very important, because safety, it should be safe to use, isn't it? Any software should be safe to use, should not have agent, not corrupt other systems, or say other software, things like that. And it should give satisfaction. It should be easy to use, and it should be satisfaction. So as I said, there are 2 angles of defining quality. One is that for the functionality, reliability, and all these things for the developer, for the customer, these are important parameters. And for the users, for effectiveness, productivity, safety, satisfaction are important parameters. Is it clear up to this point? So this is what is known as software quality. But it's not easy to. So this is we have already covered. Now delivering benefits of what you do, deliver high quality software. What are the advantages? Obviously, price. Higher quality and better service allows an organization to charge more from customers. Isn't it? The Japanese products are generally more expensive than others. The Korean products are generally considered to be cheaper. So profitability, obviously, you can make more profit, because if you charge more, then you can obviously make more profit. And then another thing is that good quality product increases word of mouth marketing. Obviously, if you, as I said, that if you make a good product, then obviously you will tell your friends, say, yes, the product is good, so buy that. That's how important. Now, if you see the profitability angle, so let me tell you, now most of you have got your seniors working in different companies, and you ask them, what have you been doing? They said, oh my God, we have to work 6 days a week or 7 days a week, because we have so much work to do. But why is it so much work to do? Primarily, if you go into details, you will see that I am fixing the bugs. He's fixing the bugs. And who introduced the bugs? The bugs are the defects. And who introduced those defects? He himself has introduced the defects, because he did not do a good quality job. So in 5 days of a week, Monday through Friday, he was introducing bugs, and maybe on Saturday, Sunday, he was fixing the bugs. So that is the problem of software quality. So if you don't do any good job, it's the same thing in your assignments. If you don't do an assignment properly, then obviously your teacher will return the answer scripts and you have to do it again, isn't it? So these are the challenges. So these are the benefits of software quality. You can save a lot of time and all these things if you do a good job properly. Now, what is the cost of quality? Quality, obviously, rework cost, detection cost, prevention cost. So detection, what is detection cost? You have to detect the defects, isn't it? Somebody has to do that testing. And there is a way to prevent the defects also. Now, software development process, which you are familiar with. Requirements development, design, implementation, coding, testing, deployment, maintenance, and bug defects can creep in any of the phases. Okay, so there is nothing which cannot happen. So in the defects arise in all phases in software life cycle. Requirements can be requirements development and management. Design, if it is the design is not good, then what happens? Your performance suffers, isn't it? Suppose a web where you are developing a web-based software, and if you want to access any website, say Google or something, or for an application you have developed, it takes a long time to open it. It takes a long time to browse, a long time to search, and all these things. Obviously, the performance suffers. So then it is because of the poor design of the software. Efficiency, it takes a long time, long amount of resource, a large amount of resource, and obviously it's not efficient. So obviously the basic thing is it's not designed properly. Coding, logical errors you are familiar with, and testing, some defects is not tested properly, some defects escape to the customer, isn't it? Now let me tell you, one of the most serious problems in software industry is the requirement defects. 40% or so defects happen because of requirements. And there are two things, it is requirements development and requirements management. Can you tell me what is requirements development and requirements management? What is requirements development? Requirements development, when you the customer who gives the requirements, obviously customer is giving you the requirements because you are a developer, and the customer is paying for the service and he is telling you, yes, I want you to do this one. So he is giving the requirements, isn't it? So then what do? You record all the requirements in a document which is known as, what is that? SRS, software requirements specification, or system requirements specification, whatever it is, you document the requirements. Okay. Now this is known as requirements development. Agreed? But if the requirements development is not correct, then what happens? You develop the wrong software, which doesn't meet his expectations. Then there's another thing which is known as requirements management. What happens? Suppose you have understood all the requirements, 100 requirements you have given, you have documented everything fine in the requirements, the SRS, all the 100 requirements have been noted down, and he has signed the requirements document and everything is fine. But when you started the design, you forgot about 10 requirements. It can happen because after all human being is doing. So 10 requirements have not been incorporated in the design stage. So obviously they are not in the coding stage because the coding follows design. Then obviously it's not tested. So 10 requirements are gone. So when the customer finds out, he finds that out of 100 requirements, suppose there are 10 more out of 100 requirements, 90 requirements have been satisfied and 10 requirements have not been fulfilled at all, not have been implemented. What went wrong? That is known as the requirements management. Okay. You could not manage the requirements properly. So these are two important challenges in software industry: requirements development and requirements management. So now, if obviously there's a cost involved. If you have to correct these mistakes, there's a cost involved in fixing those defects, isn't it? Because nothing comes free. Now, if you find the defect in the requirement stage, then it's very easy to fix, isn't it? You can immediately do it. You can change the SRS and say, yes, now the requirements is done. Now, if you find that requirement defect in the design stage, then the effort is 5 times, because this has been proven by some computer advisor and other people, that this is what the cost is involved. Design stage, and if you find that defects is in the coding stage, okay, then you have to fix it. Obviously, all the defects has to be 10 times. And development testing 20 times, and when it's acceptance testing, this 50 times, and if it is a field, then it's more than 150 times. So the earlier you find out the defects, the better. Now, requirements defect, as I said, this is something which industry will understand these defects, which, as I said, is one of the very important problems. So why this happens? Because customers are not clear about what they want. That is, customers are also responsible. Customers do not understand the difficulties of making changes, because they will say, okay, fine, it's software, now it's very easy to do. You will just write some Java code and you can change it always. But it's not so. Developers are not domain experts. And one of the greatest problems is that when you people become software developers, you will become experts in Java or your .NET or whatever it is, but you will not understand the finance domain or the supply chain domain or things like that, isn't it? Because you must have been gone through some courses, but who cares? After 4 years, you forget everything. Engineers are keen on fast delivery. There is another problem with Indian software engineers that when you give them a problem, they will immediately start coding. Okay, they are not bothered about design or understanding the requirements. First thing they like is to do coding. The same thing to you. You will immediately go and start jumping code into Java or .NET, whatever you are expert on. Requirements analysis and planning take a back seat, and some requirements are not incorporated in the final delivery. What I said is requirements management fails. Now I'll give you one, this is a metaphor. It is not exactly the correct situation, but you can understand what happens in the software industry. Now requirements gathering session, this day 12 is going on. Requirements, obviously, who gathers the requirement from the customer? A marketing person. Infosys management doesn't go, not the developer goes. The marketing person goes and meet the customer and understand what the requirements are, isn't it? That's what the normal thing happens. Developers are not involved in the requirements. Now the client says, our next requirement is something big, we need an elephant as soon as possible. So this is what the client wants. So he wants, we need an elephant as soon as possible. And Mr. Ramasamy is the marketing person. He said, Mr. Richard, why don't you adjust with the buffalo, even if it is big and black? We can deliver it fast. He has got a buffalo in stock, and he is very keen on pushing that. Client says, no, Ramasamy, we need only elephant. Let me explain our current process. Explain for an hour. He explains that what is happening in that company. Ramasamy says, fine, Richards, I understand your requirement, but ours supports only buffalo. So, Samy, our central bank regulations need only elephant. And Ramasamy says, okay, let me see how I can customize. So he has got a buffalo and he wants to push it, although the client wants an elephant. Now requirements are taken. How is he taking the requirements? Bank wants a big, black, four-legged animal, long tail, less hair, having trunk is mandatory. That's what he has done, because he cannot lose the order. Okay, that is also a big problem, because he has to meet his March 30 annual target. The same was documented, signed off, and sent to offshore for development. The Chennai office outsourced to Kochi, Kerala. Oh, okay, Kochi is mentioned. I never realized it. Finally, the customization is shown to client, and client looks like this. Okay, this is what has been done. There's a buffalo with a long tail which has been fitted, and he delivers it to the client. And how does the client react? The client faints. Okay, this happens in the software industry. If you are trying to, because the marketing people get the orders and they don't understand, they don't pass everything to the developers. There's always a communication gap. Marketing people may understand, developers don't understand. There's always a communication gap. And result is, this is what is happening in the software industry. Okay, that is why the software failures are so many. Software, one of the biggest problems, we always talk about construction business we are talking about. But our software business is not as rosy as we think. Okay, we have enough software failures. We have got enough software project cancel. I have worked in Siemens. I have seen, because Siemens is a very large organization, millions of dollars, they will scrap a project. After spending say $60 million, $70 million, it's a scrap. Because it is overshot the target, somehow it's not me. So it's not, so software industry has its own problems. So creating quality software in time, obviously requirements are some of the essential things are, if you want to really do quality software, unambiguous and verifiable requirements. Requirements must be very clear. Okay, it should be clear to both the developers, for the designers, so all. Okay, the requirements must be, no ambiguity, ambiguous terms should be there. For the testers also, requirements must be developed and managed. As I said, both are important. Good project management is extremely important, as not only in the construction industry, software project management is extremely important. Okay, and this is a bigger challenge. I will tell you why. Good coordination between development and testing teams, V model. I'll come to that. Emphasize on software quality assurance and quality control. The greatest, I don't think I've got to lay on that, but one of the greatest problems in software industry is estimation. Okay, you must have gone through some on the estimation. I don't know whether it's there in the syllabus. One of the greatest problems in the software industry is time and effort estimation. Okay, because we can't estimate. Because what will happen? You have to estimate from the requirements. Okay, In construction, where we have more or less a lot of tangible things. In software, when you have to do a requirement from the requirements, you have to immediately tell, yes, this is going to take me 60 man days or 60 man hours or 60 man months or 60 man years. Okay, and you have to plan it out. But most of the cases it happens that you overshoot, isn't it? Because the estimation technology, whatever in the software industry, is not in the best possible shape. Okay, a lot of research is going on. A lot of research is going on, but then it is nowhere. We are not being. Nobody can do an accurate estimation, and those who have done the good estimation, obviously TCS, Wipro, and other companies are doing. So obviously they are winning because if estimation, if you are making correct estimation, then your quotation is correct. You will make more money, isn't it? So now the biggest, one of the important challenges is good coordination between development and testing teams. That is a V model. I wanted to talk about that. So V model is not in your syllabus or not in your book. I don't think so. Okay. So what is a V model? You see, there's a waterfall model, isn't it? Everybody knows waterfall model, iterative model. So many things are there. Okay. What is this model? Is this like is a waterfall model in a V shape? Is it like that? What is the difference between this model and the waterfall model? Everybody knows waterfall model in this room. Agreed? Okay, now tell me what is the difference between this one and waterfall model? Quick. There's a requirements design coding. It goes sequentially. The water is falling. No problem. But then there's a parallel. There is something called functional system testing, integration testing, unit testing, and shown by dotted lines. What is that? They're connected by dotted lines. So what happens? When does testing starts? When does testing start? Requirements analysis, then functional and system testing cannot start because the code is not there. Okay, you cannot start testing unless you have a tangible thing, isn't it? And what is the tangible thing? There's a code. Code will come to you at the end after coding. Agreed? But what you can do, you can start designing of test cases. That is why functional and system testing, there is a dotted line. The testing team, whenever the requirements are frozen, immediately as a SRS, copy goes to the testing team. Because normally people have a separate quality team, isn't it? Called testing team. So immediately test, yes, this is the requirement. So let me design the test cases, isn't it? Because testing is a difficult business. When similarly there's unit testing, when the code gets ready, the unit testing test cases are written. So this increases the importance to testing. Normally what happens when in waterfall model coding after that coding and testing starts, isn't it? There's no separate design of test case. The time is allocated, isn't it? And whenever the time is shortage in any software industry, the poor people who get hit is the testing team. Okay, suppose you have already the development team has exceeded by 50%, then the time which has been exceeded by the development team is cut from the testing team. So poor fellows are always at the losing end. They never get time to test. Okay, so this is that is why the bugs go. Got it? No? Because developers are always considered in any software company. Developers in India, at least, that mentality is still there. They are considered to be the big people. Okay, and testing team. Oh, if nothing happens, you put you in the testing. But it's not so. Testing is one of the most important, challenging assignments. So anyway, once the coding is done, you can do the unit testing, and once the design is done, you can know exactly what module has to be tested integrated with what, and you can plan the integrated test cases. And functional and system testing can also be done when your test requirements are getting done. Now, as I said, the important thing which is there is quality assurance and quality control. What is quality assurance? Quality assurance is a preventive activity. A set of activities designed to ensure the development and maintenance process is adequate for the system to meet its objectives. And quality control is the testing or inspection, things like that. I'll quickly come to those things. Quality assurance, you have seen in Pressman's book also, it is there. Quality assurance is umbrella activity. So it defines all these requirements. Processes. Okay, I'll come to what the process is. It in software quality assurance encompasses all the phases of software development, like requirements development, requirements management, design, coding, testing, everything. So they say, software quality say exactly how it is, these things have to be done. And quality control is a verification and validation of for software correction. So this is a prevention step, quality assurance prevention, and this is a correction step. If your mistakes are already done, you should correct it. Now, what is quality assurance? What is the process? Okay, what is the process? So everything, like if you want to score high marks, okay, what will you do? Obviously, there's a process involved, isn't it? You have to wake up in the morning. You should have a clear-cut plan, isn't it? You have to wait early, 6 o'clock to 8 o'clock. You should study, come to the college, attend all the classes, go back again, study, something like that, isn't it? And you should also look up the previous year's questions. So say there has to be a process for getting, isn't it? And if you want to do haphazard way, there's no guarantee you'll get good marks. Sometimes you may get it, sometimes you may not. Agreed? So then, if you want to, same thing as software quality. If you want to develop quality software, then there has to be very systematic ways of doing things. Like you should collect the requirements, getting it approved by the customer, then do the design using some UML diagram or whatever it is. Now most of it is object oriented, and again getting peer reviewed. Then when go for the design, after design you go for the coding, follow some coding standards like Java or .NET or every coding standards available in the net. Follow that, get it reviewed again by somebody else, then do the testing, test cases documented. There has to be clear processes, isn't it? So this is what is known as the quality. These all fall into quality assurance. And what is quality control? Okay, I'll come to that later. So quality process is extremely important. But process is not procedure. Procedure you are already familiar with, the steps. Process is something more. Suppose you have got very good, software, okay, but your hardware fails, okay, or you have done your assignments. Let me tell you, in your assignments you are all ready with it, but your system crashes. And what happens? You cannot deliver. You cannot show it to your supervisor, isn't it? So this process. So your process has failed. So you should have taken a backup of your code, put it in another laptop, and shown it to continued your work. So user specifications, procedure, skills, nature, people, everything is a process. I gave a very good software to a person, but he doesn't know how to use it because he doesn't have a skill set. Then obviously it will suffer. Coding will suffer, isn't it? The process encompasses all the things, all the 6 parameters, and if one of these fails, then obviously the process has failed. So people are important. You can take IIT or from your college, they can take the best of the people. But if the organization can have good technology also, they will have some high-end machines, but they don't know what to do with those. They don't know how you should code, isn't it? You may be individually being a very good Java coder, but the company does not have any processes for doing Java code. You can write Java code, there has to be somebody who will review that. So these processes are extremely important. And all the companies which are in the top have very good processes. So as opposed to focus on people, process is most important. And what are the process standards? The quality assurance is quality of a product is largely determined by the quality of the process that is used and to develop and maintain it. There are some Hubert Humphrey, who was not Hubert Humphrey, it's Humphrey, who was of CMMI, said that the quality of the product is largely determined by the quality of process that is done. Okay, that is why some quality standards have come, and one of the important standards which have come is, I'll tell you, this is the major process, ISO 9001. Okay, let me tell you this. This is CMMI. Okay, 1.3. So this is a capability maturity model integration. All the companies which are known to be quality, like TCS, Wipro, Infosys, in here, Nest is there, no? Nest, I think this is also level 5. These are also CMMI level 5 company. So it can CMMI, I don't think it's in your textbook, but this is very important. Whenever you go to any company which is coming to your placement and all this, there will be level 5 company. So it means that they are in top of the quality assurance. They have defined all the processes. And what are the processes they have to define? If you are level 1, then you don't have to care for any process because they are not good for, they're good for nothing. Then if you are level 2, then basic project management has to be done. What are those things? You must know how to manage the requirements. There are different processes for all these things have to be defined. 1, 2, 3, 4, 5, 6, 7. There's in that row you can see 7 processes have to be defined. Project planning has to be done. Project monitoring has to be done. Supplier agreement, measurement analysis, configuration management, all have to be done. If you want to go to a higher level, then 14 more processes have to be defined. Okay, and then that is the development, technical solution, product integration, verification, validation, all these things have to be done. Then if you want to go to level 4, then 2 more have to be done. So you have to satisfy 23. And then if you want to go to the top, organization innovation, 25 processes have to be done. It means that you should know exactly how you're going to do all these things. You got an idea? Got an idea? This is known as CMM, Capability Maturity Model Integration. CMMI 1.3 is the version currently running. And it has been developed by the Software Engineering Institute of the Carnegie Mellon University. Okay, this is the American standard. Now, Americans, why did they come with a standard? And this is known as European standard because ISO. Americans don't like Europeans, Europeans don't like Americans. Okay, so this is a European standard. This is slightly lower level, it is not as rigorous. So this ISO 9000, you have seen, petrol pumps are also ISO 9000, security services are also, education institution, I don't know whether this education institution is ISO 9000 certified, but a lot of these organizations are ISO 9001 certified. You have seen in several places, it's all ISO 9001, 2000 certified. You have seen, nah? Have you seen it? So these are ISO certified. Okay, this is nothing to do, ISO is nothing to do with, ISO 9001, 2008 has nothing to do specifically with software, but it can be applied in any industry, including software. Okay, like it has got management responsibility, resource management, more or less the same things are there, but ISO is considered to be easy to satisfy than CMMI because CMMI is more focused on software. It is not applicable to other things also, systems engineering, but is more software oriented. Okay, management analysis and all the management. So most important person in any quality drive is the top management, CEO. Okay, the chairman of the company. I believe when Azim Wipro wanted to go for Six Sigma, you know Six Sigma and else, I'm not going to that. Then the person who was trained on Six Sigma was Azim Premji himself, the owner of Wipro. Okay, because he felt that yes, the top man must be knowing. Anyway, Narayan Murthy, when he was driving the quality in Infosys, he himself will drive it because it doesn't happen without. Suppose your organization wants to go for ISO 9000 or so, the CEO of the whoever is not only the principal, the board of management, the chairman of the board of management must to drive. It has come to the top because the management is extremely responsible. Then research management is there. You must be given all the requirements. Suppose ISO 9000 in academic institution, what will it mean? That you have to be given computers, you must be given all the good teachers, so many things will happen. That is known as resource management. Then there will be processes for taking classes and all these things. And then measurement, analysis and improvement. As Smitaji told, that a lot of people have done very well from this college. This is measurement, analysis and ways of improving. Okay, so you can measure how many people are getting distinction. You're not autonomous, no? You're not a deemed university. So how many people are getting distinction? How many people are getting first class? How many people are getting gold medals? So many things can be done. So the improvement can happen. Anyway, so this is ISO 9000 and another one. I'm going a bit fast because there are a lot of things. And I have 20 more minutes. Okay, so so these are the you have got an idea about what is this? Huh? So these processes have to be defined. Any organization which you go for, they will say, what is this? You know what something about us? You can see the net in the say, they will say, I am CMMI level 5 company. But thanks to Indian companies, the CMMI has also come down. Okay. Now being most of the companies are level 5 companies. So CMMI standard Vithora now going down. Okay. Anyway, but the American companies are very difficult to get because okay, so there are some processes to be defined and all these things. And then these are the processes, about 25 processes are defined, clearly defined. It does not mean that when you go to, suppose you join Infosys and you will find that everything is very well defined. No, it is project certified that you maybe there some aberrations can always be there. That project might not have been selected and certified. When the audit happens, that might not be done. Anyway, but generally level 5 companies are much better than 0 level or level 1 or 2 level company. Obviously, because the processes are all defined. So this is how it is, maturity level 2, maturity 3, 4, 5. It's like a pyramid, it goes up. Okay. So now coming to quality control. Another important thing, now you have understood what is quality assurance. Is a prevention activity. You have to define how we are going to do the different steps. Okay. Now in your things, what happened? You must have defined, and you always have to satisfy some examination, isn't it? What is that examination? It's nothing but testing. The teacher is testing your knowledge, isn't it? That's a quality control. And if you get 60 out of 100, then obviously you have to do some correction, isn't it? There's scope for improvement. Agreed? So that is what is quality control. Okay, quality assurance you have defined, yes, you have studied. But in spite of studying hard, you may not get 100 out of 100. There's no guarantee. Because the questions may not be clear, or you might not have studied those things. So many things can happen. So then the testing part comes in, because then the teachers will give you question paper, internal question, external question, so many things can happen, tests will happen, and then finally you will get some marks. And if you want to improve the marks, obviously in the next exam, you have to study hard and things like that and correct the situation. Isn't it? Agreed? So that is what is happening in software. Anyway, there are two things in quality control, verification and validation. These two things are very important. What is verification? You must have heard this term. There were in CMMI, there was two terms, verification and validation. There are different terms. What is verification? Have you made the product right? And validation, have you made the right product? What is that? There is the user needs, defined design as per specifications, implementation, output. So what is verification doing? And there's a very validation like that. So what is the difference? Tell me from this. You can make it out. Verification is starting from the design as per user needs, so as per specifications. Okay, and output is given. Okay, so you may see the design, that elephant case is the verification passed, but validation failed, because verification, yes, what the requirements were there, the developers have done exactly like that. Okay, but there was a gap in that user needs and design as per specification. There was a gap. Got it? No? User needs was not correct, because that fellow wanted an elephant and you wanted to do with a buffalo. Understood? So you don't meet the user needs. Suppose you develop a software. Suppose Americans don't play football; they play baseball. If they say you develop a football as per the specification and give it to an American, and he will say, "Get lost. I wanted a baseball." Isn't it? Validation is sometimes what happens. In some cases, what in the rockets you have seen, ISRO rockets sometimes, now of course it's reduced. Previously used to fall into the sea, isn't it? Because what happened, the verification was all done. But poor fellows cannot do validation, because you cannot go on sending rockets every other day and test it. Okay, how will they do? They will do on a simulation. Agreed? Before you do any expensive or any like aircrafts and all these things, you have to run it on a simulator. And if the simulator is not correct, the validation, verification will be perfect, no problem. But validation will be imperfect, because in a real life situation it will not work, isn't it? So anyway, so verification and validation, there's a difference. Verification means you should meet the user specifications, and validation means it should work. The user needs should work, and in a real life scenario is exactly what the user wants. That is validation. Okay, so you have to test both. Have you made the product right? Verification, yes. Have you made the right product? Validation, that is a validation. Okay, because the customer may say, asking you for something else, and you might have developed something else. How verification to what is inspection peer review, because you're asking your friend to go through it. Same thing you can do with your code, isn't it? What is known as inspection or reviews, and what is testing, but you don't run anything. Inspection is normally done statically on your code. or when the code is not run. But if you run it, is known as testing, which is dynamic verification. Okay, same thing, verification, but it is dynamic. Now requirements analysis, you see these are the phases. Requirements analysis, no code is there, you can only do a static verification. Agreed? R is there, review or inspection, whatever you call it. Okay, there's a difference between inspection and review. Let's not go into those things. Reviews. Then design, again you do a review. Okay, you cannot run it because you don't have the code. Then coding, then you can do a review and you can do unit testing, integration testing, system testing, acceptance testing. And there you can do this testing. Okay, so the reviews you can do at after the end of requirements analysis. You can do at the end of design. You can do at the end of coding also. That's code. So the reviews are extremely important. In most of the companies or level 4 companies or level 3 companies for that matter, reviews are very, very important. Okay, when you join the company, reviews you have to do. Okay, there will be senior people who will say, okay, let me see, you have written a code, let me see how you have written. Similarly, when you do the design, there will be a design team who will come and do a review. Why? You eliminate the risks of doing a bad job. Okay, understood? So reviews are extremely important, and which you are not familiar with being an academic environment, but in the industry, reviews are must. Now, research has shown that if you do a review, then chance of you finding bugs. Now, there's a purple line here. What is a purple line showing? Injected. Injected means that the number of bugs which are present. Bugs are the defects. Okay. Purple line is showing there are so many defects already present because for some reason it has happened. And if you don't do an inspection, then data detected without inspection is a blue line. But if you do an inspection, then the yellow line. It means that you are able to capture more defects than if you do an inspection. Okay, inspection is extremely important. Why is it better than testing? A lot of defects can be detected by inspection. It does not go through testing because normally testing is laborious. Testing takes more time, isn't it? If you can, if your friend tells, don't write this one, there's an English in mistake, then before your teachers point out, you can correct it, isn't it? Then obviously advantages are there. So inspection is extremely important. So in industry, inspection is practiced in all spheres, requirements reviews. Inspection is discussed very well in details in this book. So reviews are there, design can be reviewed, code can be reviewed. After code review, you can always do a testing. The testing can always happen when the code is ready. Okay, please don't forget that part. Now, sequence of testing, I'm not going to go into sequence of testing. There are a lot of different types of testing. Unit testing, what is unit testing? White box testing, isn't it? You test the code. So white box testing, there are different methods of white box testing. There are at least 6-7 few types. And then they got the integration testing. You know integration testing? Different types of integration testing is there, top down, bottom up. All these things are there. Sandwich integration is there. Then functional testing, non-functional testing. So most difficult type of testing is functional testing. Okay, most difficult type because you have to test the functionalities. There are so many things can happen. Okay, white box testing, the control was, I'm not going to go into details. There is no time. Cyclomatic complacency, definitely leave this out. Integration testing. Now the most important type of testing, which is important, is the what is functional testing? You should check the functionality. Like this person has developed a web-based application, online registration, investment, market info, so many things are there, and you have to check the functionality. There are different approaches to functional testing. State transition testing, logic-based testing, syntax testing, use case testing, Petrinet testing, domain testing, all these things are there. Okay, different about. Now I'll give some examples. State transition testing. Now suppose you want to IRCTC. You know IRCTC? Railway ticket. Okay. What happens if you want to buy a ticket? That's a web application. Okay. Well, in a web application, what happens? There are different sequence of steps, sequence of states it goes through. There's a sequence of events, and the next event happens based on certain input conditions, isn't it? Agreed? State transition testing is used when the system can be represented by a finite state machine, and is a behavior model which outcomes depend on the present state and the current input and represented by state graph. Okay, like here, make a reservation. He gives an input, make reservation. It's a very simple example. Pay money, he can pay the money, or he can cancel it, isn't it? Pay money, paid, yes. Then he can cancel it. After paying money, you can always cancel it, isn't it? Then, or if you paid, go right way, then you could probably ask for the ticket, it goes, and then probably give ticket. It's the right path. But in all these cases, you paid, you can always cancel. In each step, you can always cancel. In your software, you should design like that, isn't it? But if you have to test this software, so you have to develop, so you have to model like this in a state transition. Agreed? And you have to develop all possible scenarios. Test it for all possible scenarios, isn't it? It can happen that he just pays the money, ticket used, simple scenario. But you should always be able to do that he pays, cancel it at every step. So you have to test it. Agreed? So you have to model the software in terms of the state transition testing, and you have to design test cases so that these state transitions happen. Okay, this is known as a state transition testing. Then there's another called logic-based testing. In some cases it happens. You see this example. Insurance premium charge may be stated if the age is more than 50 years and income is less than 2 lakhs, the insurance premium is rupees 1,000. It can happen. You can encounter these type of cases. Agreed? So you have to have a different methods of testing this type of application. These are functional testing. You have to test the functionality. So you can, you are defined by a decision table. Okay. This have condition, accounts, credit, balance, so many things are there. There are different rules are there. And this rule is satisfied, then this happens. Okay. So you have to model. It all depends on how you model the system. There are different methods of so far. There are different methods of modeling the system. Logic-based system, syntax testing. Like when you go to ATM, there's a password, isn't it? You ask a password. It will say, after say 1 or 2, if you don't not correct properly, not input correctly, it will say password is wrong. How does it do? Because you have already defined certain syntax. Okay. Then you have defined maybe your name is XYZ, 1, 2, 3. XYZ. After that, it is if you put a reject. Syntax is not correct, isn't it? So that is known as syntax testing. Similarly, use case testing, very important. Use cases, you know, if you have known UML diagrams, use cases. Now everything is done by use cases. So use cases help you. Similarly, for real-time system Petri-nets, Petri-net testing, and equivalence class part of boundary value analysis there in your syllabus. You will read it or you have already gone through it. Now, what is in use case testing? Use cases are like this. Actors are there. System is. You must have seen use cases, isn't it? UML diagram. So you're on in your syllabus. So every activity can be done by use case, and you can check. Like this is a use case system login. So you can check. You can give the sequence of activities and see whether it is correct or not. But there are cases. So its testing is very, very difficult job. Okay. And for this modeling the system, as I was telling, the testing is not as easy as you think. This modeling the system with the right thing is not an easy matter. There can be several issues. Okay. You have to write the syntax. Nobody will tell you the syntax. They will give you a system and say, now you develop your test cases. Agreed? So you have to model and find out what exactly the grammar. Okay. So you have to find out all the things. Similarly, if you have to model the state transition, once the model is correct, then only you can design the test cases. Here you can have different paths. I think there are six test cases are required for testing this. Okay. Got it, no? Because you have to test each and every path. Okay. So there are different types of testing to be done. Now, important, I wanted to go, what is a non-functional testing? Yes, non-functional testing, there can be several types of non-functional testing. Like performance testing, configuration testing, compatibility testing, security testing, reliability testing, efficiency testing, usability testing. I think there are 14 types of non-functional testing. Okay, these are all required. Okay, load testing, security testing. Security is very important. Reliability testing, how reliability is. and installability testing, maintainability testing, documentation, even documentation has to be tested. Suppose you buy a mobile phone, if the documentation does not match how you are using the mobile phone, then you will be getting irritated, isn't it? Some of the mobile phones, I got one, is very, very scary, very scanty. It doesn't help. The mobile data documentation must be detailed. Recovery testing, then portability testing, graphical user interface testing, internationalization testing. Suppose you have developed a software in English, it has to be translated to Japanese. Internationalization testing is very important now. Now with the work of globalization, you may have to translate into Spanish. It has to be tested, isn't it? That is internationalization and localization testing. Okay. So then this is application secure, this is application hard to use. These are all different types of testing has to be done. So these are important. So there are tools available. Similarly, acceptance testing is there, alpha testing, beta testing. Now let me tell you what are the challenges in testing in brief. I've already given you an idea. What are the challenges in testing? Comparison of the actual with correct values determine the quality test case. Now you see, when you are testing for the first time, you have given a software, you say test, give it a test. You don't know actual result. Agreed? You don't know actual result, because how will you test? Whether you know the test case has passed or failed, you don't know. Because the actual results are not known. Agreed? No one will give you the actual result. They will give you the SRS. Now you find out the actual result, whether it's passed or failed. So software and testing, there's a test oracle. You have to write a test oracle, which does a mimicry of the system by simulation or something like that. Okay, scientific things are easy to test because you can do a calculator or so and say, yes, the value will be 5 or 6 or whatever it is. Okay, but general other things becomes difficult. So you have to test oracle is there, which is mimicry of the system, and you can compare the result. Determine the quality of test cases. Sometimes it happens that the test cases itself are bad. Agreed? It can happen because the tester may not have done a good job. Test cases are bad. It can happen. So that is you determine by mutation testing. What is mutation testing? For the software, I create a deliberate error, mutant. I create a mutant. So I introduce a fault and find out whether the test case is finding the fault. That is mutation testing. Okay, I create several mutants. I do like this. In original, I create a mutant. Here, I put it was greater than, I put a greater than equal to symbol and find out whether the test case which I have developed is discovering the error or not. Okay, there is a mutation testing. This is also important. This mutant killed. Okay, the mutation testing is there. Extremely important thing. Then exhaustive testing, as I said, is very, very difficult. Choose wisely, cost-effective, time-tested, risk-based, tool support. Tool support is there, but choose wisely, risk-based. Now coming to how much testing is enough. Okay, that's also because there is no, as I said, whenever there's a shortage of time, there's a testers who get a cut. Okay, but how much testing is needed? Can you predict test effort like your project management effort estimation? Test effort estimation is a very difficult thing. It's more difficult because once a defect is found, it goes back to the developer. Okay, agreed? To correct the mistake. He might be introducing more defects, or he can correct that because of side effects, not deliberately. But if you saw the side effect in a software, one of the greatest problems is side effect. If you make one changes, it can affect changes in other places, isn't it? You make one variable change, you make it global variable or whatever it is, and that itself will create problems in other places. There's no side effect. So software is very, very tricky. If you want to make one changes, it can reduce the defect, you can remove the defect, or it can introduce 5 more defects, which is known as side effect. So because of that, effort estimation is very difficult in testing. Okay, because side effects, you never know. Wow, it depends on the quality of the fix. Now, how much testing is enough is very, very unpredictable. Okay. Now coming to the point, what practically it is done is that you do risk-based testing. When you go for an examination, how do you check? Do you have time to read the entire contents? Cannot be possible. You have got 2 days after the 2 days examination is there, isn't it? But you have got entire, say, 500 pages to read or 300 pages to read. It's not possible for you to go through it, all the pages or all the possible questions. You take a risk, isn't it? You take a risk. The last year these questions have come. This year is very likely that this will not. Agreed? So you take certain probabilities that yes, these questions are quite likely to come this time. So read more on those. And if those questions which are not expected come, you somehow write something so that you can get a pass mark. Agreed? The software developers does the same thing. They find out what are the weak areas, what are the areas which the customer is going to check. Test those portions very well, or the risky portions test it very well. And those who are more or less they are confident, no, there is no time. Because time is an issue. Got it? No? So time is an issue. So they always take risk of missing important faults, risk of incurring failure costs, release untested or undertested software. Next version they will be doing a better job. But this time, since delivery date is there, do it. Got it? No? Risk of losing credibility and market share, risk of missing a market window, risk of over testing, ineffective testing. So there's a risk involved. So there's a risk testing. Risk to determine where to place emphasis, risk to determine what to test most, what to test first, how thoroughly test each item, where to place emphasis. They also do the same thing. And what not to test. Use risk to allocate the time available by testing or priorities in testing. Okay. So testing, prioritize test so that whenever you stop testing, you have done the best testing in the available time. Got it? So as I said, so I am not going to metrics for software quality. Time is running out. So, but as I said, testing is a very difficult job. It's not as simple as people. In this country, testing is considered to be a low skill job, which is not correct. Testing is one of the most difficult jobs because it needs a lot of analytical. They feel that, okay, only developers need analytical skills. It's not so. It's the testers need more analytical skills, much more than others. And then there's another portion is called metrics. So I'm not going into those things. Leave it out. I think with that I close for the day. Okay, because any questions or
So you have mentioned about non-functional testing 40 times. Is there any common tool available for testing?
a lot of tools are there. I didn't give, but it's all given here. There are tools, all open source tools. You should practice.
Common tool is there.
Huh?
Common tool for all 40 times.
Yeah. No common tool. Some tool is used to be testing. But there are tools available. It's all given here. But you can go through that also. And there are different, lot of open source tools are there. Okay. Even for the unit testing, where students are studying in Java program, they should use those tools, open source tools like Java testing tools. That will do for them when they go to the test. In this book, we have discussed all the tools and all the areas what are the tools available. So I will strongly recommend to use this book. Obviously, it's for the students and it's very easy to use. Okay. Any question? I think we have understood it.
Again, what's like the next big thing in computer science that we students in
Cool.
next moving field of computer science.
Moving field in computer science is big data. Analytics. There's a huge demand for analytics.
Thanks.
Big data analytics is because our smart cities. Testing is always there. Okay. Even analytics, testing is always there. Quality is a lot of job opportunities there. Big data, unstructured data. Because smart cities and all this have a huge amount of unstructured data. We don't know how to process it. Okay.
Sir,
Hold it.
what do you think is the future of service providers like Infosys and Wipro in India?
There are no other options because we don't have any products. So it is not that we lack of Indian talent. We have a lot of small work. But the global market, we have also seen that they have to come for product. And they don't care. One product sells, we buy it. The one product doesn't sell, they don't care. Okay, but Indian people don't cannot afford that. That is the only successful company. But Indian global marketing is very different. Because it's a very control, they now see so many markets that right. They are copying up. They are competitors. Okay, they don't care. Cisco will buy some company, the Oracle will buy something. Whoever is coming up, buy. That's why Indian companies are getting sold. They're happy being getting sold as $1 million or whatever it is. And Americans have just the computer association is a group because of their acquired company. They know that they don't want to manage. Same thing with HP, same thing with IBM. They have become global companies because they're global companies. Okay, not the whole inherent technical skills. The companies might be being owned by India in India now, and of course Indian companies. But there might be companies in somewhere also they have simply taken over. So buy the intellectual property. If you have money, you can pay for it.
Thank you.
Any other question?
So, how do you think the entrepreneurship or startups are going to shape the future of our nation?
Startups have a good, you can have a good idea, you can develop, but will you be able to survive and make it an economically profitable venture? That is the important issue. It's ultimately boils down to finance. Got it, no? And if you are really doing well, then there will be 500 companies, at least 5 companies will come and say, okay, give the product, I'll buy it. Why are you wasting your time? That's what I was telling. There will be 5 companies who will come up and say that, okay, you give me the product, I'll buy it out and you take your money and go. Or you join our company. That's what has happened. No? You join our company and as a technical person and continue to do this product and for 2-3 years. Normally they will not keep you for a long time, 2 years. After that they will say get out. Understood what I'm saying? You can have good ideas. I'm not saying that there is any dearth of ideas in this country, but making a good idea from making it a product, becoming a financially successful, there are a lot of things. And these you cannot survive on because again another feeling is that you cannot survive on the Indian market. Now how many of us go and buy an Indian product? You tell honestly. How many of us will have that Indian nationalist? I have worked in CDAC when we were Param. We started importing crane. We don't have the nationalist feeling. We are not China that we can be forced. We will immediately go out. We will always buy an American product or a Japanese product or even a Chinese product, but we will not touch an Indian product. Agreed? With this mentality, how can you survive in this Indian market? You cannot survive. I may be blunt, but it's a fact. How many of us go and buy an Indian product? If we see the same product, I have maybe an American one, okay, fine. I'll go for a Japanese one. Or maybe slightly more expensive. I will not have anything, okay, I'll buy an Indian. That nationalism, patriotism is not there. Unless now the government is trying to force, make in India and all these things. So there will be a lot of people. But the question is that people are within the country. But so somebody has to financially ask if your parents are supporting you, you can do it. Okay. Any other question? CSI, because I don't know, we do a lot of conventions, a lot of programs. Okay, whether you attend these programs, I don't know. We have recently published, we have started publishing a CSI Adhyan. I think a lot of people yesterday, I was talking to Balakrishna, he was also not aware of this. Okay, I've told them that publicize it more. A lot of activities don't get are publicized because we cannot reach the members. It is a fault in our system. We are trying to correct the system because I just took over, and we are trying to correct the system. And there are two things. I will be addressing Cochin chapter tomorrow morning. There are two things. We need to bring the industry people to CSI, as well as for the academicians. Is more important the research papers, conferences, quality of proceedings, so many things. But for the industry, they are interested in networking. Okay. And there has to be some way of doing it. Even in this college, you have a student batch, you should invite some industry people to come and talk under banner of CSI. And they are all ready to share. I am happy to say that I have seen very, very good professionals, IT in the industry, who are ready to share their. So I think we should take advantage. They don't expect any money or any favor because they have got enough money. So it is a question of that we have to involve them. So it is up to the student branch and teachers to follow them. And even I don't know about the IT industry in this part, but you can always get somebody coming from somewhere. But that will help you to understand what exactly is happening in the industry, because a lot of things are happening. And obviously, I don't know how many big companies are there in this part. I am not. But CSI has only a platform, so you can use the CSI, you can whatever it is under CSI. There's no restriction. Again, it's a Make in India organization. We don't have to go to Americans to get any permission. We operate from Bombay and we can do anything we want. Okay, but we are trying to improve things. I know there's a gap, but we are trying to improve. Any other question?
India, in software sectors, mostly we are using freeware software in order to make programs, such as Python and all, which do not give us much security guarantee. And also, this freeware we are able to customize them. India, in many of the institutions, we are using freeware, so that we are not getting the projects from foreign countries easily, and disadvantage for our studies. And also banking and all other sectors, while using this freeware, don't provide much security if we use paid versions.
There is no harm in using freewares, but you see, something which is free obviously will not have any guarantee. Got it? No? So you have to test it before you use those software. But there is no harm. If the software is a basic platform, it's secure, then you can always develop software applications on top of that. But unfortunately, most of the open source software is not as secure or error free as we would like it to be. Agreed? Because they're free. You are not going to give them surveys. Fine. But there are a lot of things, Linux and all this, I believe it is stabilized. There are so many versions of Linux, so many things have been operated. Open source software, I was talking to TCS, global head, who works only on open source software. I was talking to him 15 days back. In fact, you can invite him also. I can pass his number. So they are saying that I told him, why don't you tell us what are the software, free open source software, which is for which area, and which are more, because TCS, they said his job is to find out if the customer wants to have one based on open source software, they will develop on that. Understood? Because the cost reduces, because he doesn't have to, customer doesn't have to buy this platform software. So they checked that one. So I said he's the best person to advise on what are the open source software which is available, which are reasonable, well respected, and more or less free of bugs. So a lot of work has been happening. Primarily the industry is doing a lot of things, but as you said, I agree with you, there are challenges available. But I can, I've been talking to him that organize some programs and give a write-up on those things. I'll have to chase, because he's also very busy. I am also got out of that. Okay, but But there are umpteen number of things which you can do in academic community also. Okay. But these free software which I was talking about are written in my book or whatever it is, they help you to get a basic idea. Because industry, when you go to say some company may join them, you'll be trained on that particular software. But this will help you to know the basics. At least you will know, and you will find a lot of interesting, and you never know when you can come back with a better software idea. Because this helps us, helps in coming up with some new ideas on, and you can develop on top of that.
Thank you so much, sir. Now we would like to give certificates of appreciation and cash awards to the students of Computer Science Department of SJCET for their contributions to Raerest 2016. I request Dr. Anirban Basu, President of Computer Science Society of India, to give away the certificates. I invite Mr. Don Abraham of S8 Computer Science Department to receive the certificate of appreciation from our chief guest for the creation of website of Raerest 2016. Now I invite Mr. Reno Varghese George, the man behind the promotional video of Raerest 2016, to receive the certificate of appreciation and cash award. As a token of love and gratitude, we would like to present a memento to Dr. Anirban Basu, President of Computer Science Society of India. I welcome Ms. Smita Jacob to give away the memento. Thank you, sir. Thank you, ma'am. We are now coming to the end of this function, and I welcome Dr. S.G. Balakrishnan, Professor of Computer Science Department, to deliver the vote of thanks.
It's my pleasure. Welcome to one and all gathering here. And it's my pleasure to deliver vote of thanks at this gracious occasion. It's my privilege to thank Dr. Anirban Basu, President of Computer Society of India, who come over here in his busy schedule. Also, he delivered a valuable inputs in software quality with interactive manner. Thank you, sir. Let me thank HOD of Computer Science and Engineering, Miss Smita Jacob ma'am, who always encouraging us to conduct these kind of events in pleasure manner. Thank you, ma'am. I also thank the management, the organizing team of Raerest 16, the teaching faculty members and non-teaching members of our department and also other departments. And I would like to welcome and thank the participants of this conference who comes from various places from Kerala and also outside the Kerala to expose their ideas. And also I thank the press people and audio-visual arrangement peoples. Last but not least, I thank all volunteers and students from our department. Thank you, one and all.
Thank you, sir. And here we come to the end of this function. After the lunch break at 1:30 p.m., we will have the presentations at 3 venues of this block. Thank you.